So let's look at what are we going to do today. We'll look at what is big data. We'll understand what are the limitations of the existing solutions. Why do we need something like Hadoop? Okay, we'll also understand how does Hadoop solve the problem. We'll be introducing you to Hadoop. We'll look at the various components of the Hadoop ecosystem. We'll also look at the core components of Hadoop, which is HDFS and MapReduce. We'll go into details of HDFS architecture. We will also understand how does the MapReduce job execution work. We'll understand terms like rack awareness. We'll also understand how does a file read and write happen in Hadoop. And then we'll also take a sneak peek on the Hadoop 2.0 architecture. Okay. As I said earlier as well, that most of the production sites still use Hadoop 1.0, but we have introduced Hadoop 2.0 now. We want to be, there's some stable release of Hadoop 2.0 have arrived. So you will be well acquainted with how Hadoop 2.0 works. Now I'll take a few questions right now. So if you have any questions, just put it on the chat window. Before I get started, I can take questions on generic things. Okay. Okay. So if you were planning to come in the first class, yes, this is the right class. So we've just started the class. Okay. So don't worry if you've not missed much. Okay. So Venkat is asking, is Java mandatory for MapReduce? Well, yes, not mandatory. I mean, you can do MapReduce programming in Python, Perl, Ruby as well, but most commonly Java is used there. Okay, so you can, and there are sessions, Java sessions available in the LMS. So in case you do not have Java knowledge prior to this, you can go through them. You don't need J2E or advanced Java. If you understand course Java, that's good. That's good enough, Prashant. Okay, so there's another question. So we will be doing all our work on Hadoop 2.0. We will be doing things on Hadoop 1.0 as well as in 2.0, both. Because see, the fact is that most of the places where you go, you will be using 1.0 only. But we've introduced 2.0. Okay. Okay. For the practicals, we'll help you set up just after this class. There is a session which you will have to undertake. You will be setting up the VM on your system itself. So you can definitely play around Venkat Subramaniam, or you will have an environment to do that. Okay, so for Hadoop we will be using Ubuntu, but you can set it up on either Mac, you can set it up on Windows, okay, or you can set it up on Unix. Okay, so you need to know a little bit of Unix, Elvin. There is a set of Unix commands which are available in the LMS. If you go through them, that should be good enough. You can connect to a remote session as well, but yes, the VM will run on the Mac OS as well. So don't worry, all the questions related to the VM, I'll answer at the end when I'll be talking about it. So don't worry about that right now. There was a question that will I be able to clear the Hadoop developer exam using this course? Well, if you properly follow this course, I can assure you, you can clear any exam. Okay, you can clear any developer exam. As well, more than clearing the exam, you'll get a very good hands-on. You'll be able to work on a project directly if you follow this course properly. So Bhanu, don't worry about that. But make sure that you follow the course properly. Attend all the classes, do all the assignments properly. Wherever you need help, take the help from the support team. Okay. Okay. So same question there. How much Java is required? So see, you need to understand core Java. Okay. It is necessary to understand core Java to do programming. Okay. But there is a set of Java questions, Java lessons which are kept in the LMS. In the third class, we'll require Java. By that time, you have enough time to actually go through it. And if you need any help, the support team is able to help you out. Okay. I'll just pick up. Okay. Utpal is asking what is the major difference between Hadoop 1 and Hadoop 2. Utpal, very early to ask this question. I'll ask you this question after the end of this class. I'm sure you will be able to answer that. So I'll be covering that in this class. Okay. Now there is a question on how to test Hadoop architecture. Don't worry, you will get to know that as well, Satish. Okay, as we move ahead in the course. Okay, so right now, if you have any question on how the course will work, that is the question will be really useful if I can answer right now. All other technical questions, let me cover the topics and then I'll be very happy to take them. Okay. Pankaj is asking, will edureka provide any certification for Hadoop developer? Yes. So based on this certification is not based on the multiple choice questions or anything like that. questions, this certification is based on your project work. So you do the project work, we'll review the project, and based on that we'll be certifying you. Okay. So let me go ahead and let me quickly show you the LMS and show you most of these questions will be answered there. So this is your learning management system. As you log in, this is where you reach. So first part talks about Java Essentials for Hadoop. So this is where you can get all the lessons. There are lessons here, there are assignments, there's PPT, code, and everything is available. Go through these parts. Okay. Then this is the Hadoop installation setup. I'll talk about it a little from now. So you have for everything on Mac or how to do it remotely, and everything is there. And this is where your class recordings will be available. So this class which we are taking right now will be available at this point after say 24 hours. Within 24 hours you'll be getting that. Okay. And this is where you will find an old batch class recording. So you can before coming to the class, you can actually, if you want to go through, you can go through those classes as well. Okay, there'll be quizzes, there'll be assignments here. We'll also be putting a few more things here, like specific interview questions which you may encounter over a period of time. So we have collected them. This will be available in your each module. So for example, in HDFS module, you'll find the interview questions for HDFS. And this is work in progress, so it will be up as we go ahead in this course. Okay. Okay. So let me go ahead, and some of the questions I've intentionally not answered. You get answers to that as we move ahead. Okay. Okay. So what is big data? Now I'm sure everyone has heard about big data. Everyone has done their own research on big data till now, and they know what is referred as big data. But let me also tell you what big data is according to me. Now, not very different than what you've thought. It's lots and lots of data. That's what it's called. That's why it's called big. Now, it is not in megabytes or gigabytes when the data reaches terabytes and petabytes. And if the data is really large and complex in the sense that it is not not just structured data, a lot of unstructured and semi-structured data is called big data. And there are a few definitions associated with big data where they say that, okay, big data, when you have large amount of data flowing in your system, okay, at a big speed and a big variety of data like big streams from, if you click on something on say a like or a share on Facebook, that contributes to big data. Large amount of videos, audios which are shared is big data. The amount of data which is the kind of data which is shared in say the customer data which you get, the kind of customer behavior data which you get in large organizations, that contributes to big data. Why are people so crazy about big data these days? What does big data help in? Anyone has an answer to that? So I'm getting some answers there. Very good. Data insights and analysis of various parameters which can be done. A lot of information can be extracted. Right. Hidden insights about the business. Very nice. Analytics. Right. So yes. So this is basically the motivation about. See, everyone had a lot of data. It's not that data has come today, but there was not many ways of analyzing that data. Okay. So with tools like Hadoop coming in, it has become much more easier to analyze that data. Okay. And you can do predictive analysis, you can do trend analysis, you can look at customer behavior, you can run specific campaigns for customers, you can do say a fraud analysis using big data. So lot of domains are finding applications there. It's all started with social media, but now I mean right from banks to retail, we'll be looking at some examples to government. Everywhere people have started realizing the power of big data analytics. And they are doing analytics there. Okay. Now there is an example here which says New York Stock Exchange generates about 1 terabyte of new trade data per day to perform stock trading analytics to determine trends on optimal trades. Now, if you look at 1 terabyte of new trade data per day, and no trade analysis is done based on a single day data, right? It is done based on a data over years or months. So you can imagine the kind of data you have to crunch, and you need to have all that data in single place, and there has to be a tool which can actually crunch such huge amount of data. Okay, we will be looking at so that's the amount of data we are talking about. Now there are various applications, various places where you will find this data. Mostly the data which we deal with when we talk about big data is unstructured data. What is the difference between structured and unstructured data? Anyone can answer that? Okay, structured has row and column. Yes, unstructured could be a log file, right? Raw data is unstructured, right? Okay, right. So yes, so whatever is stored in RDBMS, you can say that that is structured, and everything else is either semi-structured or unstructured, right? So data from, say, click streams, which you have, audio, video data is all unstructured data. Okay, let us look at more examples of unstructured data. So basically, this is a very important graph which plots how did the growth of data happen. So till say 1990s, there was hardly any unstructured data available. Now whatever data we had was business transaction data, which was used in banks. The kind of data you'll find in a CRM, you'll find in a in a banking transaction. That was the kind of data which we were dealing with, completely structured in rows and columns and tables. With the growth of application data happened mostly in the new millennium, when we got with when Google came up, when other search engines came up, and social media came up. A lot of people started analyzing that data. I mean, for social media, for example, sometimes they had no other way but to look at that data and generate a revenue model out of it. Right? How does Facebook earn its revenue? What is the revenue model of Facebook? Can anyone tell me that? Ads, right? So how does Facebook make sure that the right ads are shown to the right people? If they're not able to show the right ad to the right person, then they'll not be able to make any money, right? So as an advertiser, I can target people in Facebook. Yes, context-based advertising by using the activity log, by looking at your what you've shared, what you've commented, the kind of pages you like, right? Where you are located, in fact, your workplaces. All those things are parameters. I would request everyone to actually go ahead and try to create an ad in Facebook. That could be one of the activities for today. You'll get to know the kind of parameters they look at, okay? And based on those parameters, they are able to show you ads, right? So Lija says, I'm able to see a lot of edureka ads now in FB, right? So Facebook knows whom to actually target. Okay, Alvin also tells me that I found edureka ad in FB and that's how I joined. Okay, a lot of people here got to know about edureka and FB. So edureka will be advertising a lot on Facebook, and they will be advertising because they get a ROI on that, right? If they do not get a ROI on that, then they will not advertise. So they pay a lot for Facebook advertising, and what Facebook has to make sure is to target the ads to the right people, right? Okay, so basically before the advent of, say, Hadoop, or before people were storing data in Hadoop came in around 2006. People were still storing their data on distributed, say, MySQL, okay, instances, or on Oracle Exadata. Okay, I'll show you that as well as we go ahead in the course. I'll tell you how to do that. Now, at this point of time, the data, see, it is not that data was not there. Data was always there. The unstructured data was always there. This is where this would be the point where probably Hadoop started getting in use. And since then, you see a lot of unstructured data. In fact, it is said that every year the amount of data in the universe is doubled. Okay, so Exadata is a Hadoop is a Oracle tool. Okay, 2009, 2010, Oracle introduced that. You can read about it, Oracle Exadata. Okay, now what has happened now is that with the tools like Hadoop, as well as a lot of BI tools which have been introduced, which can work very well with Hadoop, doing analytics over this data has become very simple. Okay, earlier it was not possible. So say Facebook uses Hive. Hive is one of the things which we'll be learning today to do a lot of analytics over the data. Okay, so we will be learning about Hive as well as we go ahead in the course. Okay, so this is what has happened in terms of data. The data is growing very fast. That's all I wanted you to know from this foil. So if everyone has an understanding of what is the difference between structured and unstructured data, and how the data is growing these days, then I think we are good at this point. So can everyone give me a yes if you understand that? Thank you very much. Okay, Savita is asking you what is unstructured. So Savita, all these, as I said earlier, all the data like click streams, audio, video, all this data is classified as unstructured data. Anything which is not in the form of row and columns in RDBMS is unstructured data. Okay. Okay, coming to IBM's definition of big data. It characterizes big data with three things: volume, velocity, and variety. Now, what does volume, velocity, and variety mean? Very, very simple to understand. In fact, very logical as well. Okay, Prashant is asking me a question. I'll quickly answer that. Is the Facebook chat unstructured? Yes, that is also unstructured data. In fact, Facebook was using Cassandra earlier for Facebook chat, but then they looked at the Facebook Messenger is built on HBase. Okay, so we will be looking at that when we reach the HBase class. Okay, but the volume means the amount of data which is being generated, which we know it is huge. Usually data in terms of terabytes and petabytes is classified as big data. Velocity is the speed at which the data is getting generated. Now, if you look at it, you'll see that, okay, Facebook is generating 500 terabytes of data every day. Okay, or NYSE is generating 1 terabyte of data every day. So this velocity is defined there. Okay, and variety is the kind of data which is getting generated. See the chat data which Prashant talked about, or the data which was audio files, the click streams, the video files. All this is a huge variety of data which is getting generated. There could be unstructured, semi-structured data as well. Say XML kind of data is a semi-structured data. Okay, so this is how it is defined. Now there are a couple of questions which I'll quickly take here. So Ananda is asking, there are analytics software like SAS, Teradata, etc. Do they work only on structured data? No, Ananda. They can also work on unstructured data, but you'll have to, usually what you have to do is there is a stack of data flow which will ultimately end up on SAS. In fact, on Hadoop also you can use SAS as a analytics software. You can use R with Hadoop as well. R is a very commonly used open source language for analytics, which is fast replacing SAS. Okay. Now, in Hadoop, you can use all data. You can use structured, unstructured data as well, Savita. Velocity, as I said, Prakash, is basically the speed at which the data is getting generated. As we saw, right, the NYSE generates 1 terabyte of data every day. Facebook generates 500 terabytes of data every day. So that is the huge amount of data getting generated every day. Well, Ashutosh, this definition of big data is very vague. I mean, different people will look at it at different ways. So it's not that all three have to be there to classify it as big data. Jatinder has asked me this question. Aadhaar card data seems to be structured but very huge. Is it also a part of big data as it is structured? Well, in fact, Aadhaar uses Hadoop. It also uses MongoDB, and it is not just structured, it is unstructured data also. They take your retina view, they take the fingerprint, they take your photograph, all that is also stored. So approximately 5 MB data per candidate is there, okay, per person. So for people who are not from India, Aadhaar is like your social security system in US, and where the data of each citizen is being taken, and there'll be a card issued to every citizen. In fact, a lot of you will have the cards there. Okay, so that also uses Hadoop. Okay, so let me introduce you to Annie. I would have liked her to be a little younger, but nevertheless. So Annie has been introduced in this class. She will be asking you questions once in a while, so that you can think about what has been done till now. And once in a while, Annie will jump in and ask you questions, and you'll have to answer them on the chat window. Okay? So let's see what Annie has. Now, Annie has a question for all of you. Can you quickly do that? Can you map the following to corresponding data types, which means classify them as either unstructured, semi-structured, or structured? All of you. What is XML? Okay, good. So XML is semi-structured, that's right. Word docs, PDF files, text files. You can answer these questions here. Think about it. Email body of an email. Very good. And data from enterprise systems, ERP, CRM, etc. Okay, great. So I think most of you have got the right answers. Let's see if Annie agrees with you. Okay, so Annie says XML is semi-structured. Now what If you've not understood what semi-structured is, then semi-structured data is like XML files where there's no, it's not as structured as your row and column, but it is still has some structure like a XML file. Okay. Docs are completely unstructured, right? And data from enterprise systems. How many people got all the questions right? Okay, very good. So all of you got the questions right. I hope now if this question comes, everyone will be getting it all right, right? So everyone has understood the difference between structured, unstructured and semi-structured data. You've also understood what is big data. Okay, the kind of data which can be classified as big data. You've also understood the IBM's definition of big data till now. And you've also understood the rise of unstructured data in the last decade or so, right? Okay, XML, if you look at XML, right, there is no fixed definition. Okay, there will be so many columns, or there will be width of a column or the size of the column. So that is not there in case of XML, right? You can have as many columns, you can have as many, it has tags, right? But there's no restriction there. So that is why it is called semi-structured. As compared to say a Word doc or a email body or an audio video file which is completely unstructured, XML has some structure to it, right? You can extract some structure out of XML, so it is usually classified as semi-structured. Is that clear to everyone who did not understand that? Venkat, Lija, Savita, can I quickly get a yes from everyone? Good. Thank you. Okay. So let's move on. So till now you've understood a lot of things. Let's see what is next. Okay. So I will also suggest that, I mean, not everything, as I told you, right? You will have to do a lot of homework as well. There's some things here. You can go and read this blog, The Hype Behind Big Data. You'll get to know a few things here. Then why Hadoop also is a blog on Edureka blog itself. I suggest that you read this as well. You'll have links to each of these already in your email. Then people who are looking for jobs in Hadoop, this is the place where you can go ahead and look at. You can also search at Indeed. You'll find a lot of jobs there. Also, you should go and read at Wikipedia about big data, and then big data characteristics on the IBM definition. This is the link. So after the class, you can go ahead and do some reading here. Okay, so see, usually in a ERP or a CRM, right, usually you will have a structured data. I mean, it may have, say in case you're uploading a photograph of each of the places, that will also get unstructured data, but usually it will be, I mean, if you look at, you define how your tables in a CRM will look like, right? So, and you also specify this is the data type of the column in CRM. That's why that data is all unstructured, all structured. But you can also add, say, a profile picture, so that will be unstructured. But still, the overall, when you define a table in CRM, you define, or you define columns in CRM, you will be actually looking at what will be the data type, whether it will be a drop-down list, and what will be the kind of columns it will have, whether it will be numerical or whether it will be a string data type. So all those definitions you do. That's why the CRM data is called structured data. I hope that this answers, right? Okay, great. So yeah, so these are the further readings after the class. You can read about these, and you'll get a lot more insights into it. Okay. And if you have more questions on it, you can post them either on the discussion forums. I'll show you where to put in the discussion forums as well quickly. So this is where you'll find the discussion forums. You can go ahead and start. You can ask questions. You can go through a lot of discussions are happening here. There will be discussions on your certification exams as well. This is one discussion which is happening here. Okay, so if you need to file a ticket, you can file a ticket from here. Okay, you can also call on this number or check your ticket status from here. These are the forums. Yeah, you can start a new topic here as well. Okay. Okay, unstructured data usually will not have a structure. Okay, that is why it's called unstructured. It will be completely random data. It may have some structure, like there will be some data which will be a comma separated data. There will be some tabs in between, but then it will not be a predefined structure. Okay. Alvin, you can definitely interact with all the participants in this class through the discussion forum. Okay. Okay. So in this section, we will be looking at some of the big data customer scenarios. We'll be looking at what are the use cases where people are using big data analytics. Okay, so eBay, for example, is using a lot of it in web and e-tailing, which on eBay, if you've gone there, you'll see a lot of recommendation engines which will say that, okay, the people who bought this also bought this, right? You've seen that, something like that, everyone? Has everyone seen that? If you try to check out something from either eBay or a Flipkart, it will say, okay, people who bought this also bought this. So that recommendation engine is done using big data analytics. In fact, Mahout is the tool which is used on for doing that, the building recommender systems. Okay, I'll talk about Mahout as well, so don't worry about that. Then ad targeting, I've already spoken to you about ad targeting, where on a specific customer you can target your ad based on his behavior. So that's one place where people use big data a lot. Improving the search quality and click fraud detection. So for example, if you have ad on Google and there is someone who keeps on clicking that ad once on every time using a bot, for example, Google has to make sure that that ad is not charged for. Okay, so even if you go and click a single ad 100 times on Google, it is not that the advertiser will be charged for that. Okay, so that's also done using big data analytics by looking at who is actually doing that. Okay, then in telecommunications, there is China Mobile, which is a large. I mean, Airtel also uses that. A lot of Indian mobile companies also use it. In fact, a lot of companies in the US also use Hadoop right now. So for network performance optimization, calling data record analysis, all this call data, for example, is unstructured data. Right? It's audio data. So if you have to do some analysis over that, if you have to look at, okay, and if you have to look at the performance of your value-added services schemes, so you have to analyze huge amount of data. How many people actually got and used that particular top-up plan which you gave, and what was the churn from there? That is the kind of analysis which we do using Hadoop here or big data analytics. Okay, and you also analyze your network to predict failures. So we want to know more of our customers. Say for example, if I know these many customers use this kind of schemes, okay, so what I'll do is that I'll probably introduce a scheme where these customers will be, say for example, let's take an example. Now I have a segment of young customers who use a lot of phone in night, okay, but they are looking at competitors which are giving them free night talk time, okay. So that will lead to customer churn for me if I've not got that data analysis properly, okay. And if I have got that data analysis properly, I'll be able to prevent that customer churn by introducing a scheme like that. Does that answer your question, Vivek? So customer churn prevention is understanding your customer behavior and introducing specific schemes for our customers or a set of customers so that they do not go to competitors. Okay. Yes, Gmail also uses Hadoop. So everyone understood what is customer churn? Say for example, you are a mobile provider. Okay, you are AT&T for example, and you see that you want to know what my customers are actually doing. Okay, how many people actually use the night talk time schemes? How many people actually use the unlimited SMS kind of schemes? How many people use the email package scheme? Okay, so based on that, you will introduce new value-added services. Okay, and if you are able to analyze huge amount of data, you will be able to predict that which scheme is going to work well, which is not going to work well. So, and you will also be able to prevent customer churn, which means that your existing customers went away to some other provider because customer churn is like attrition, right? So your customers went from this provider to some other provider because he was providing a better scheme. Nowadays, you will see a cutthroat competition based on talk times, or right. So that is what is churn. It is CHURN here. Okay, so is that understood? So these are all the places where in telecom big data analytics is used. Okay, so network performance optimization. Again, see, you know how many people will be using a particular at a particular time. What will be the usage of your network, right? Say for example, at night 3 o'clock, if I have a huge amount of network bandwidth available, but very few people using it, it's of no use. So you can route it to some other place. Okay. Say for example, I don't know how many people have noticed it, but since I look at these things very closely, if you go to your office on weekends, right, you'll see the network speed is bad. Okay, or late evening hours, the network speed is usually bad. Or on weekends, though you have a 10 Mbps lease line, but still what Airtel will go ahead and do is that on weekends they'll route a lot of this network to the homes, okay, to the individual retail users and not from the corporate users, because they know on these weekends very few people will be using it. Similarly, in the night time, you'll see at times the speeds will vary. Okay, so basically what they have to make sure is that based on how many people are using how much bandwidth, they will be doing a performance optimization. Does that answer your question, Avni? Has anyone noticed this happening in their offices in the weekends, that the speed goes down? Though very few people are there and you'll be wondering, Venkat says yes, that why is the speed today down? So it's not your system admin who has done anything wrong, it's your network provider who has done some smart optimization of the network. Okay, there are a few people who have said yes. I'm sure when you others go ahead and notice this, if you go to your office today, you'll see that the speed is low. Now, you've understood the application of big data analytics in retail. You've understood the application of big data analytics in telecommunications. Let's look at some more applications. Okay, Aadhaar. Now, again, someone had asked this question earlier. Now, let me tell you what Aadhaar is. For people who are not, does everyone know what Aadhaar is? I'm sure there are a lot of people who are not in India, so I'll quickly tell you what Aadhaar is. Aadhaar is, okay, Sarita says no, okay. Don't worry. Aadhaar is a scheme which is introduced by Government of India, which is like social security number in US, where each citizen will get a unique identity, which will have, using which they can get rid of, and hopefully get rid of all the multiple identifications they have to carry right now. It has your photograph, it has your fingerprints, it has your eye retina image, okay, so, and it has your address and your everything. And if you look at this picture itself, it has the thumbprint, right? So it has your thumbprint. It's not very different from the social security number in US. Okay, it is not very different. Now for each user, it is said that they have 5 MB data. Now if you look at India's population, I don't want you to calculate it, but it will be somewhere around 10 to 15 petabytes of data. Okay, and every day a lot of analysis will be done on this data. So Aadhaar is using Hadoop for storing this data. They also use HBase. Okay, Venkat Subramaniam has told me that Aadhaar is world's biggest biometric database. Right, I'm sure it will be, because India is the largest, if not today, then it will become most populous country. So Aadhaar is using Hadoop. Then Next Bio is a large organization in the healthcare and the life sciences space. It uses for gene sequencing. Now, I'm not an expert on that, so don't ask me what all can be done using gene sequencing. I'm sure some of you guys, you can read about it. I can send you a few links. I know as much as you guys know. But this is the idea of putting it here is that this is one area where big data analytics is being used in a huge way in the health sciences and in life sciences. Right. So you can predict that what will be the kind of disease a person may be having, what could be the possible solution for that. And what I'll say is that you should also look at this link, which shows you, I'll quickly take you to this link, but I'll let you people see this link later on. Now this link shows what are the different companies which are using Hadoop, for example. Okay, and what is their node size and what are they doing with that. Okay, so this will be a good read. You'll come to know it's an alphabetical indexing of all the companies which are using Hadoop. Okay, so you should go ahead and read this as well. Okay, now there is Ananda has given me a good insight. He says that your genome sequence is mapped to the behavior, to find the behavior against a database to find your health behavior. Right, so genome sequencing is this, it is mapped to find the behavior against a database. So there will be a huge database and your gene will be mapped to that to find out what could be the diseases you may catch or what could be the probable solution to that. Okay, so let's see what are the other use cases. Now in banks and financial services, JP Morgan Chase, for example, one of the largest banks. In fact, all the top 5 banks use Hadoop. Okay, in fact, 3 of the top 5 banks use the cloud era Hadoop itself. Okay, so what are the kind of things which they use for Hadoop for? Basically, for modeling true risk. What that means is that you have to look at, okay, with a particular loan or with a particular transactions, what could be the risks associated with it. Say, for example, a lot of insurance companies actually use big data analytics. What do they do with it is that looking at your past records in terms of payments and looking at your health records, they'll predict, okay, this should be the premium you should pay. And based on your region where you live, the kind of salary you earn, your premiums will vary and the kind of schemes they can offer you will vary. Okay, so these are the applications in the financial services domain. Okay. A lot of things like credit scoring analysis. Everyone understands credit scoring? Okay. Ananda is asking, bank data is mostly structured. How is then big data? Okay. Not exactly, Ananda. I mean, bank data in terms of the transaction data is structured, but a lot of data about customer behavior is unstructured, right? Based on which you will be figuring out what has been his history. Okay, that will be completely unstructured. A lot of data about the region the customer lives in, the kind of, so this individual data may be structured, but then you look at, there's a huge volume of that data. Okay, so though some of the data will be structured, but the volume itself puts it in the big data space. Okay, now retail. Coming to retail, we will also be looking at Sears. Sears has a very interesting use case. I'll be going into some detail there. Now, point of sales transaction analysis, again, customer churn analysis or sentiment analysis. What does this mean? Okay, so when you go to a retail store, if you go to a retail store and if I know that you had visited me, say 3 months back, and you bought something from me, and at this point of time, I can give you an associated discount on a particular thing. I can say I am the person who's selling you, I am the cashier there. Okay, you came to me and I told you, hey, do you know you have a discount on black shoes because you bought say a black suit a few weeks back, and we have a running discount on black shoes, black leather shoes. If I knew this data about this particular customer, and if I know, okay, this customer is most likely to buy something like this if I give him a discount, or say, for example, a customer who is very high on electronics, whenever a new thing comes in, he comes and buys it, and today he has just come to buy something else. If I give him a discount on that, that's something which will really help me in selling more. So that kind of analysis a lot of retail stores do now. Has anyone seen that on, say, a Walmart or a Target or Sears anywhere, that you get a customized discount? On Amazon, yes, you've seen that. I'm talking about retail stores. Initially, they used to offer something like this, that okay, on your birthday they'll offer you something, or on your birthday month they'll offer you a small discount, so that you will be prompted to buy more, right? But now they want to do even more. So that is one static data which they have. They want to do based on the customer behavior. They want to offer you discounts. Or okay, Venkat says I've only seen in online, not in a store. Okay, but yeah, you'll see that in a lot of places. You may not have noticed that at times, but a lot of these point of sales transaction analysis is done, and in fact, some people use SAP HANA as well there. Good. So basically, in all applications, if you see this, the common thing in all domains is that you have huge amount of data. Okay, SAP HANA is a database. Yes, it's an in-memory database. Okay, Prakash. You can read through, there's a blog on SAP HANA on the edureka blog, you can read through that. Coming back to what is common in all these scenarios is that there's a huge amount of data which is flowing in at a very fast rate, and each domain wants to know their customers well. They want to know their performances better so that they can optimize their resources. They want to understand, say, they want to understand the customer behavior. They want to understand their salesperson's behavior, and they want to give better service to their customers, as well as want to earn more money from the same customers, right? So by giving a better deal to those customers as well, right? So that is the thing which is common in all these scenarios, and hence the application of big data analytics is quite ubiquitous. Okay. Now there is a question. I'll take some questions now. Does big data contain only huge unstructured data? Is the huge structured data not a... Yes, so if the data is huge and it is at a very fast rate, it will be used for big data analytics as well. There was a question on, please explain credit scoring. Okay, so what is credit scoring? Now, if you are a customer of a credit card, right, or you're taking a loan, so they'll always ask you for your credit score, right? Okay, so what does that mean? Based on your past performance, right? How well you paid your loans or your credit cards, there is a credit score associated with each individual, and based on that, you will be offered a differential rates on the next loan which you take, or say for example a credit card which you take. So does that answer your question, Prem, on credit scoring? Okay, so Prem says, I was working with Deutsche Bank on credit analysis, but we are not using Hadoop. Now, see, it is not just that all the time you will be using Hadoop. When the data becomes huge and you really want to, I'll show you an example and you will understand where Hadoop will come into place instead of other, let me just go to the next. Okay, so this is case study on Sears Holdings. Sears is a retail store, okay, a mid-sized retail store. Now what they did, what they were doing earlier was that they were using a combination of Teradata, Exadata and SAS to do data mining. Okay, they were using a traditional system like Exadata, Teradata, and to store and process customer activity and sales data. And they wanted to understand how do their customers behave. Okay, now they were not using Hadoop earlier. What did they want to do? What did they want to come up from there? The same thing which I showed you just now in the point of sales. Okay, they wanted to understand how are their customers buying, what are their buying patterns, when do the customers buy, what are the kind of things they are buying, what could be the associated things they can buy if a particular customer is buying something, so that they can offer them deals and discounts, as well as they can map their behavior properly. So earlier they were using system Teradata, Exadata combination along with SAS. Now there were some issues which they were facing because of which they shifted to Hadoop. Let's see what was the challenge there. So you can also read at this link why Sears is going all on Hadoop. So this is one link which you can find in this PPT. This PPT will be available in your LMS. So you'll be able to look at this link as well. Now what was the challenge? So basically this is the place where you collect the data. From the instrumentation, your point of sale instrument, you collect and you store the data on a grid. Okay, so it will be a huge data which will be stored. Initially, what happens is that 90% of their data was getting archived. So after a period of time, this data becomes too huge to handle in this storage grid, and they were archiving this data. The storage here is a grid of computers where you are storing your data. Okay, this is not Hadoop. Usually, your storage area network kind of thing. And what you will be doing on this will be that after some time you will be archiving some data. Okay, at any point of time the active data which is available for processing is around 10% of the data, and 90% of the data is archived. Okay, so you have limited availability of data to analyze. Say for example a customer came 3 months back, you will not be able to look at that data. Archiving refers to putting that some data from an active level 1 storage to a level 2 storage like a tape, or to a level 2 storage, which is not actively used for analysis. Okay, so you in your offices you would have seen that there will be a tier 1 storage, there will be a tier 2 storage, then there will be everything will be stored on a tape going forward. And you look at the archive data only when there is a problem or something goes wrong, you pull that data back to do that. But then the challenge there is that if you cannot store such huge amount of data in an active tier 1 system, and that is why you could analyze only 10% of that data. Now if you analyze only 10% of that data, because the challenge here was that if you move it to a ETL compute grid, you will not be able to do that because of the limitations there. Now this data goes into RDBMS, then you run your BI and interactive apps basically to get an insight on the customer behavior. Okay, so let me repeat this once again. What is happening here? Here is your instrumentation and data collection. This data is getting stored into a storage network. Then a lot of this data gets, this is all raw data, a lot of this data gets archived over a period of time. This data is moved into a ETL thing where you do extract transaction load. Everyone understands what is ETL? Right. Okay. So ETL will be used on this raw data. Okay. So we will be reading this raw data. We will be extracting meaningful information out of that data, and then we will be generating reports out of that based on the business requirements. Okay. So there will be some SQL querying done there. We will be looking at more into ETL as we go into this course. But for now, you can understand it this way, that it will be, you move the data into a data warehouse, okay, where you will be analyzing this raw data, you will be reading this raw data, and you will extract refined data from this raw data, okay, and then move it into and generate reports based on that. Okay. Sushil is asking me what is premature data death. Now, see this, 90% of this data doesn't make it at all to the compute grid at a particular point of time because of the huge size of the data. Okay. So the challenge here is that only 10% of the data is available at any point of time to generate interactive reports which can give you insights into the customer behavior. Okay, so that's what Sears was also saying. And what they did was something like this. So they removed this complete ETL and the storage grid with Hadoop. Okay, now this complete data is available at any point of time to do analytics. Okay, you don't have to archive any data. You can actually put all the data together and do all the analysis together. Okay. So the challenge which companies face is not about storing that data. The challenge is about retrieving that data at a very fast rate and putting into a ETL kind of system. Okay. Now what happens is that the storage sizes have gone up. They have scaled up beautifully. What has not happened is that the read speed from a storage is not increased. The read still happens at a very low speed. Okay, we will be looking at that in a while. So because of that, it is impossible to read all that huge data without using something like Hadoop. And I'll be telling you why, okay, in a while. So just hold on. Some of these things will become clearer as we move on. For now, you can just understand that with Hadoop, you are now able to utilize your complete raw data for analytics as compared to earlier system where you were using only 10% of that data. Okay. So the performance of getting data and everything we'll be talking about in a while. Okay, you will understand all those things. Okay, is that okay? Is everyone fine with that? So see, the crux which you need to understand here is that because of the limitation of not being able to get that data from a ETL, from a storage grid, okay, we had to archive a lot of data and we could use only some data. Okay, now Hadoop has solved that problem and you have the complete data available for analysis. How is it different from the storage grid is something which we'll be looking at in a while. Okay, we'll be also looking at security in Hadoop, not in this class, but later on, Satish. Okay, so is that clear to everyone, guys? How has Hadoop changed the fact that you can now analyze a larger amount of data as compared to a lesser data earlier? Yes, Satya. So that's right. This is not only an issue of storage. It's not an issue of storage. You can store data, right? But can you actually quickly retrieve that data to do analysis? Let's see. I mean, I understand that all of you had that question on the last foil that why can't we analyze the whole data when it is kept, whether it is archived, it can still be retrieved and it can be analyzed, right? So let's see what is the challenge there. It's not about storage. This small example will help you in understanding that. Yeah, Utpal, please go ahead and ask your question. But meanwhile, what I want you guys to do is that look at this problem. So you have to read 1 terabyte of data. If it is kept on a single machine, which has 4 IO channels, which means it has 4 hard disks, and each channel has the read speed of 100 Mbps, which means it's a very good sophisticated machine. How much time will it take to read it? Okay, I want you guys to calculate that. Utpal, you can go ahead and ask your questions. Don't worry. And meanwhile, everyone, please try to do this exercise. Tell me how much time it will take to read 1 terabyte of data from here. Okay. So basically, this is the kind of time it will take. It will take around 45 minutes. To be precise, it will be somewhere around 43 odd minutes. But 45 odd minutes it will take to read 1 terabyte of data from a single machine. Okay. So all of your storage networks when they are not distributed reads, will take this much time to read 1 terabyte of data. You can imagine if you had 500 terabytes of data which Facebook generates, how much time will it take to read that data? So the challenge, guys, is not about storing the data. It is about reading that data fast for analysis. Now, if you had 10 machines, if you had to read the same 1 terabyte of data from 10 machines, what will be the thing? How much time will it take? Yeah, obviously, it will take 1/10 of that time. So this is the whole idea behind introduction of a distributed file system, and that is what Hadoop is based on. Okay, it is not on processing power or anything like that, but it is on the ability to distribute the data. Okay, and a framework which can store distributed data as well as help in analyzing that data without facing all the issues like scheduling of data read and dirty read. All those things are taken care by the framework itself. Coming back to the same slide, if you look at, if you had a normal storage, it would, why do we archive all that data? Because it is not humanly possible to read that. It is not possible to read that data at a fast rate, right? So if you had to do that analysis, the importance is that the analysis should be done at a very fast rate itself. In case of Sears, they have moved to a 300 node Hadoop cluster, and to keep 100% of its data available for processing rather than meager 10% as was the case with non-Hadoop solutions. So what Hadoop does is it can distribute the data, and you can read data in parallel from Hadoop. Okay, so if you have 300 node cluster, I'll tell you what does that actually mean. But in this case, you can read from 300 nodes in parallel as compared to one very fast storage area network kind of solution. Okay, does that help in understanding this? Now is this much more clearer? But for now, have you understood how does Hadoop help in this particular case by making, how can we analyze all the data together? Because of that problem of reading that data fast, what we did was, instead of putting that data on a very high machine, a highly available machine, we put that data across a cluster of computer which are say in this case a 300 node computers from which you can read in parallel. And though the speed of read from each will be slower than what you could achieve by vertical scaling, which means by using a better hardware, but you still can read from parallel from hundreds of nodes, so you have all the data available for analysis at any point of time, right? Is that guys? Yes, data from point of sale, right? So does that answer all the doubts which we had at that point of time earlier when we were on this slide? Okay, so can I assume that it requires more investment on more nodes to process? Well, very good question. Now the fact is, with Hadoop, it becomes very cheap. One, Hadoop is open source, you don't have to pay for the licenses. Number two, these nodes are not really high-end machines, as we'll see as we move ahead, that these are cheap commodity hardware, so the price will be in fact lower. Okay, so that is the beauty there. Okay, Satya? Let me quickly move ahead. So we've seen that this is the problem we were facing, that that's why we needed a solution which could distribute the data, but still now, yes, so basically there are a lot of distributed file systems available. Now Hadoop also has its own distributed file system, which is called HDFS. We'll come to that. And Hadoop is not only about the distributed file system. Okay, how to arrive at the value of your 45 minutes and 4.5 minutes. So 1 terabyte of data divided by 100 MB per second divided by 4 will give you this number. Okay, Satish? Okay, so Ananda, Hadoop is not only about a distributed file system. I'll just give me some time, you will get to understand that as well. Keep that question in your mind. By the end of this class, you'll understand that. Okay, so till now we are clear, guys. What we have learned till now is that there are various applications of big data analytics. We understood, and you can keep giving me a yes if you agree with what you've understood, whatever I've told you till now. So I'll Prem, to your question, Hive is the ETL tool in Hadoop itself for doing the ETL. Okay, for data, it is the data warehousing tool in Hadoop. So you don't need to integrate with some other tool. It will take care. Let me quickly go through what has been covered till now. Okay, so those questions, as and when we cover that, I'll be answering that question. So we've understood the application of big data analytics at various places. Okay, and we've also understood how did Sears move away from Exadata, Oracle, Teradata, and a ETL-based solution to a Hadoop-based solution, so that they could get so much availability of the data to analyze. And then we understood why is a DFS required, and what is the need for a Hadoop kind of system. It is not just storage, but the power of doing processing in parallel. Okay. Now let's look at what is Hadoop. Okay. Now Hadoop is not just a distributed file system. Hadoop is a framework that allows for distributed processing of large data sets, as we've just seen, across clusters of commodity computers using a simple programming model. Now, though I'm not a big fan of definitions, but this one is a good definition. So Hadoop is a framework. Now there was a question that there are many other distributed file systems available. Google has one, the Red Hat ones has one. Hadoop also has a distributed file system. So Hadoop is not just that distributed file system. It is a complete framework which allows you to do processing over large data sets across clusters of commodity computers using a simple programming model. And this simple programming model is called MapReduce. And we will be looking at that as well as we go ahead. So in Hadoop, you can scale up to any number of nodes in a cluster. What Hadoop does is that it gives you the power to distribute your data across a cluster of commodity computers, and these could be as big as 10,000 nodes, okay, where your data is stored and it can be retrieved in parallel. It can be, a lot of parallel processing can be done, distributed processing can be done using a programming model called MapReduce. Okay, and we will be going into details of each of these things as we go ahead. Okay, and it is an open source data management with scale out storage and distributed processing. So it's an open source data management tool. Now the key features of Hadoop, we will also come to know about them as we go ahead in the course, but for now it is economical. Economical, why? Because one, there's no license cost associated with it. Even if you're buying a Hadoop from Cloudera or a Hortonworks or say MapR, which are different distributions of Hadoop, you still have to pay only for support. The distribution is free of cost. Okay, so it's more like Red Hat Linux and not like Microsoft Windows. Okay, so it's economical there. Reliable, the system has been built in such a way that when there are failures, you still have data availability. Okay, and we will be looking at that. There's something called data replication, node replication. I'll be teaching you that. I'll be talking about that today in the class itself, so that you come to know that how does the system remain reliable as well. Okay, flexible in the sense that you are not constrained by the number of nodes. You can keep on adding nodes on runtime. How do you add nodes? What is the effect of adding nodes on the admin module is something we'll come to know. But for now, you can understand that you can really delete and add nodes without putting the system down. Okay. Scalable, it is largely scalable. There's no limit on the number of nodes you can add, and basically your solutions like Teradata and Exadata cannot work for if the data becomes large than say 10 terabyte. Okay, so that is where Hadoop comes into play. Hadoop can process really large data sets, maybe in the order of petabytes as well. Okay, and there is no limit to the scale as such. I mean, theoretically, there is no limit to the scale. Okay, so Annie is back and she wants to ask a question. Hadoop is a framework that allows distributed processing of, okay, very simple question. Now, the reason why this question is put in is that it is not that you cannot handle small data sets. Okay, you can handle small data sets as well, but there is an overhead associated with each data distribution which happens, right? So now if you have small data sets, you will not be able to get a huge advantage by using Hadoop. You can still handle small data sets as well, but usually you will not use small data sets. Otherwise the overhead associated with Hadoop will be huge as compared to the overhead associated with Hadoop when we are processing a large data set. Okay, so Hadoop is not insufficient for small data, it can handle it. Okay, but just that you cannot unleash the power of Hadoop on a small data set. Is that clear to everyone, guys? So good question, Prem. Prem is asking, what if the small data set is small and unstructured? Well, if the data set is small, what you will and unstructured, what you will try to do is, at the first step, you will try to collate that data. Okay, you can concatenate data together to make a large data set. We'll see that one of that example in our class 3. When we will be looking at MapReduce, I'll show you that example as well. Okay, but usually you will try to get a large data set. Okay, there was a question which I wanted to take. Okay, Pankaj asked me, how is Hadoop flexible? So Pankaj, as I told you, very quickly I'll repeat that. You can add and delete nodes, okay, without actually putting the system down. So in that sense, it is very flexible. Okay. So if the data size is in terabytes, then it makes at least in a few GBs, then it makes sense to use Hadoop there. Data set. If it is less than that, it doesn't help. So Satya has a question which I want to answer. Technical architecture infrastructure, while it requires more storage space to store data and nodes to process used data. In this case, it involves more licensing cost. In this case, how can we recommend the client to go for Hadoop implementation? What would be our justification we can give to our client? So Satya, well, number one, Hadoop does not require a licensing cost because it is free. So that's one very big justification. You can save millions of dollars which your client would be giving on, say, Oracle Exadata. Why should you go for Hadoop implementation? Because of the scale. It is also based on the scale which you want to achieve. If your data runs into more than 10 terabytes, then it makes sense to use Hadoop. Okay, and Hadoop implementation will be cheaper than any other Teradata or a Exadata kind of implementation. Okay, I hope that answers your question. It is open source. Yeah, and also the hardware which is used in Hadoop is commodity hardware. We'll come to know we'll talk about that as well. Okay, now coming to the Hadoop ecosystem, let's see what are the different components in Hadoop. Now I'll not be going into details of these, but over the period of our course, we will be covering most of these. Okay. Okay, to start here, so basically you had a lot of data or a structured data. If you had structured data stored in a RDBMS and you want to move it into Hadoop, you use Scoop for that. Scoop is the tool used for Scoop is a tool which is used for moving the data from RDBMS to Hadoop. So it's the full form of SQL to Hadoop. Okay, it's the abbreviation of SQL to Hadoop. Okay, so this is where we'll be using Scoop. We'll be covering Scoop in the course in the class 2 itself. We'll be talking about data loading techniques. Flume is used to import unstructured or semi-structured data into Hadoop. Okay, which means that say if you have data which is on web, okay, and you want to move that data using an API into Hadoop. Say a common data could be a Twitter data which you want to move into Hadoop. Some websites will allow you to import data directly from an API. So Flume is the tool used to do that. Okay, we'll be doing an example of Flume also in the next class, and where we'll be loading data from Twitter into the HDFS or the Hadoop distributed file system. Okay, okay. Next, so this is the data which you load from the real world into Hadoop distributed file system. The next thing, the very important thing which comes into this framework is called the MapReduce framework. MapReduce framework is the and don't worry if you do not understand this completely. Okay. So about the security in Hadoop, we'll be talking about that as well, Omkar, going forward. Okay. So just hold on. I mean, not all answers can be given at this point. At this point of time, just try to understand, just get familiar with these names. Okay. Hive is the data warehousing system in Hadoop. We'll be covering that as well in one of the classes going forward. This Hive was developed by Facebook. Pig is another data analysis tool in Hadoop framework which was developed by Yahoo. We'll be covering that as well. Now, then Mahout is the machine learning framework. It is used for doing all those analysis like recommender systems, clustering analysis. All those things are used in Mahout. It is the machine learning component. Now, a lot of applications use machine learning as well these days, especially the e-commerce and your social media. They use a lot of machine learning. In fact, Mahout is being commonly used in almost all the domains these days. So this could be another thing which will be interesting, but we will not be covering in this course. It is not a part of this course. The Uzi will be covering in this course. This is the workflow management tool which is used to run jobs in parallel on Hadoop. Okay, Scoop and Flume are tools, and you need to just know the names right now. Okay, going forward in the next class, you will understand how to use scoop and flume also. Okay, for now, just get familiar with these names that is used to move data into HDFS. Okay. Now, Mahout will not be a part of this course, so I'll just quickly tell you a little bit about Mahout. There's a separate course on Mahout, so if anyone is interested, you can pick up that course as well. Okay, so Mahout is basically Hadoop and MapReduce together. What do you can write intelligent applications using Apache Mahout. You can also look at this link, which will tell you a lot of things with a lot of people who use Mahout. And these are the I'm sure everyone has seen these kind of recommendations on LinkedIn. Companies you may want to follow, jobs you may be interested in. People who saw this profile also looked at. Okay, people similar to this, I'm sure everyone has seen, right? Or the recommendation which you see on Amazon, all that is done using Mahout. Okay, Mahout in itself is a big subject, but yeah, it is a part of the Hadoop framework. So you may, if you're interested, you may want to learn that. There is a course from Edureka, I believe, which takes you deep into Mahout as well. Okay, but we will not be covering in this course. So is this clear to everyone? What are the different components in the Hadoop framework? In the Hadoop ecosystem, you have the tools for loading data, which is Hadoop distributed file system, and then you also have a NoSQL database in which you can load data, which is HBase. MapReduce framework is the programming model which is used to read and write data from this from the distributed file system. We'll go into details of all these are open source. Okay, all these are freeware, all these are open source, right? Okay, then Hive is the data warehousing tool, Pig is the data analysis tool, Mahout is machine learning, Apache Uzi is the workflow management tool. We'll be looking at each of these tools and their applications as we go forward. Yes, MapReduce framework works directly on the HDFS, and I'll also tell you what is MapReduce in a while. Okay, I'll give you a small example of MapReduce as well. Okay. Now you can, okay, good question, which reporting tool is used? Okay, so for data visualization, a lot of people use R there. R is an open source reporting tool. Has anyone heard about R? R is a library of, I mean, you can do trend analysis, you can do predictive analysis, you can do a lot of things using R. Okay, so R is an open source tool which is used in conjunction with the, it is a language in itself, it is very similar to SAS. SAS is basically very high cost license. There is open source, a lot of people are, yes, it is called R only, R, the letter R itself. You can search for R programming language. It is used in all the domains. It is used in financial domain as well, and there is a course on R as well in edureka. You may want to look at those details as well. So it is used for, yes. So you can use it for risk analysis. You can use for predictive analysis. With all this data which you have in the Hadoop ecosystem, you can use R to generate meaningful analysis out of that. Okay. Okay. So let's move ahead. Let's look at the core components of Hadoop. So Hadoop has two core components of Hadoop. There are two core components of Hadoop. Okay, one is your HDFS, which is the Hadoop distributed file system. The other one is your MapReduce, which is used for processing. Now, as we've seen, Hadoop distributed file system is nothing but a set of clusters or a cluster of machines which are combined together where the data is stored. Okay. Now, there is in this there are two things here. One is called a name node. The other one is called a data node. The name node is called the admin node, and the data node is your regular data node where the data is stored. Okay, so we will talk about more detail into name node and data node. For now, you can understand a cluster or a Hadoop distributed file system consists of two types of nodes. There is one name node and there are multiple data nodes. Data nodes is the actual node where the storage happens. Okay, and if you look at that powered by link which I pointed you earlier, you will see the kind of cluster people have built, the kind of data, what is the configuration of that machine which can be used for data nodes, the configuration of machine which can be used for name nodes. Okay. Now the data is put across data nodes. Okay. Now they are natively redundant, which means that the redundancy is built in. The redundancy is built in the sense that all the data which is present on one node is replicated on other nodes as well to avoid failures. Now, since we use commodity hardware here, we assume that the data is going to be, that the data node is going to fail. Okay. So with that assumption in mind, the way the framework works is that it doesn't store data at a single location. It stores the data at multiple locations. And how is all that managed is something we'll be learning in a while. Okay. In today's class going forward, we'll be learning that. Okay. For now, you can understand that HDFS is a Hadoop distributed file system. The data will be stored at multiple places, but what will happen is that on that, this data will be stored at multiple locations, but it will be governed by a single admin node, which is called name node, but you can read the data in parallel from multiple nodes. Okay. MapReduce is a programming model. What MapReduce does is that to analyze your data, okay, you can run your program. Instead of moving your program into, okay, let me take an example before I make you understand what is MapReduce. Let me just quickly open. Okay, just bear with me with my bad handwriting, but let's take a pen and, okay. So basically, assume you have elections happening in multiple locations. Okay, so these are all multiple booths. Let's take an example of a election campaign. Okay, these are all multiple booths. Is everyone able to see this? Yes, yes, Ananda. HDFS has complete file system structure. We will be looking at that as well. We'll go into the details there. Just hold on for some time. Let's try to understand how does MapReduce work. Now these are multiple locations where people you went and voted. Okay, people in Delhi, Chhattisgarh, in India especially, the elections are going on, and the similar is the case everywhere. Wherever elections happen, there are multiple booths where people go and vote. Okay, so say I went and voted here. My vote is registered in this location. My friend's vote is registered in this location. Okay, there are multiple parties which are contesting these elections. Okay, now one way of calculating who won is to take all these votes from here and move them across to a central location. Okay, and do the counting at this location. Okay, and declare a winner. Okay, so this is one way of doing things, right? And this is how traditional systems work, right? Everyone agrees with that. So you have so many people who have voted here. There's so many people who have voted at this booth. Take all these votes. Now assume that you did not have EVMs. You had votes. So you will carry them across and you will do the counting at a central location. Okay, right? What are the challenges here? Now these could be lakhs of booths across the country if it is a general election. The challenge is moving this data across from this place to this place. The cost of moving data is much more than the cost of doing the calculation. Right? Processing cost is lesser than the cost of moving data. Does everyone agree with that? Moving data is difficult and time taking. That's right. Very good, Maruti. Right. So what could be the alternate solution? Okay. The alternate solution could be that on these booths, you send your processing to these booths. Okay. So I voted here. You calculated at this point itself that party A got these many votes. Okay. Party B got these many votes. Similarly at all these locations. Okay. Count at the booth itself. Very good. So then, but can you declare a winner at this place? Yes. You cannot declare a winner at this place because it will be dependent upon all these locations, and together you will be able to tell whether if the party wins here, it doesn't mean the party A will win at every place, right? You need to consolidate. So what you will take from here is the data you will take from here, and you will move this data to a central location where you will consolidate this and do a processing here as well and declare a winner, right? Does everyone agree with this approach? Okay. So this is what MapReduce is. Okay, A is a party, nothing more. Prakash. A is a party, A and B are two parties. So let me talk once again about this. So initial method was that you have all the booths, you take all the votes and move them to a central location and do the processing there, right? That was the traditional approach we looked at just a while back. In that approach, the challenge was that moving data, the cost of moving data is very, very high, okay? And the cost of, and the time it takes is very high, so your processing becomes time-taking, tedious, and very difficult to do, okay? While in approach 2, what we did was we counted the votes here itself and only moved the part that how many votes did each person give. We did not move the votes literally from this place to this place, right? Data loss chances are also very low. That's right, across the network. So, so this task of counting here is called a map task. And this task of finally doing a deduction is called a reduce task. Okay, these are all programs. Now initially what the approach was to move your data to your processing. Here what we have done is we moved the processing to the data, right? Is that clear to everyone? Yes, you can do, that's right Ipsha, you can do, and all these maps can be run in parallel at multiple nodes. That is very easy to understand, right? You don't need, so there can be booth level resources who can do this counting, there can be booth level resources who can do this counting and only pass on this particular thing, right? So this is the map reduce approach of solving a problem, okay? The reduce task is again a program which will just consolidate, okay, if a party got these many votes from here, it will get the tally of all the votes from all these places and then finally tell you who is the winner. Is that okay, Richa? Yes, we are still moving the summaries of individual nodes to central location to consolidate, and that is what the reduce task will be doing. Okay. Sure, I will repeat this once again. Richa, Jatinder says, excellent example. Thanks, Jatinder. Sure. So the summary of this whole idea is, I'm sure when you read about map reduce, you will be hearing terms like moving data, moving processing to the data, moving the program to the data. This is what it actually means, that you divide the whole problem into multiple problems and solve those problems. Now, what we've done here is, since this data was available here, instead of moving the data to a central processing unit, we moved our program to this unit. So basically, you can move a map task or a map program to the data node where the data is actually stored. If you come to that, okay, and you get a consolidated winner at this booth level. Then you take these winners or from all these booths to a central location. This could again be a data node. I mean, it doesn't matter. This could be another constituency where you took all these and you did a calculation here on who is the actual winner, right? Is that clear, guys? A map is just a program. We'll come to know about that as well. Okay. It is called map reduce because the first task is called map task. The second task is called reduce task. Okay. Is this clear to everyone? Anyone has any doubt about the map reduce paradigm now? Don't worry how the map task is run, how many map tasks can be run on a node, who governs, who makes sure that the task is running properly. Okay, so on the individual poll booths, a map task can do the calculation here itself, right? The task can be completely independent. There's no dependency of this task on this booth, right? Say on booth A, you have a party candidate A which is leading, and you get these votes counted. You get 50 votes here, you get 45 votes here. Now you move not the votes but the actual number, that 50 and 45, to this task. So this is any task which can be done independent of the other data nodes can be moved into a map task. Okay. Wherever there is an aggregation required, you require a reduced job. So it is also possible that in your analysis you never have a reduced job. You can do everything in a map task itself. Say for example, if you are doing an encryption on some data, okay. Let's take an example of something like you have a lot of data, raw data kept in multiple nodes in Hadoop, and you want to apply an encryption algorithm on that data. Okay. If you want to apply an encryption algorithm, it will just be a transformation. You take X amount of data, transform it using an algorithm, right? Using a function, right? That function does not require consolidation across nodes. So you can run a MapReduce without a reducer itself. Does that make sense, guys? Okay, so I'll explain this example once again. It's a little difficult thing to get at this point of time, but don't worry. I just want to have some chaos in your mind as well. So what I said was that you have huge amount of data put across multiple nodes in a cluster, okay? And you want to run an encryption on that. You want to encrypt all that, okay? You can run that, and what does the encryption require? It requires a data transformation. You can use a function which will just take the input data and give you an output which will be encrypted data. Is that clear to everyone? So you have a function A, okay, which will take an input I, and it will give a output O, okay, right? And this is the, say for example, AES encryption, and AES is the type of encryption, right? You can, if you have say 100 terabytes of data here, you can run this function on this whole data, and this, what will come out of this will be a encrypted data, right? So in this case, you can do all the tasks, whatever is required here in a map task itself. You don't need a reduced task in this job, right? Because you don't need any consolidation. Is that clear now? Great. So, so don't worry too much about MapReduce now. We will be covering that in great detail when we get to the MapReduce class, but I just wanted you to understand the context and what is actually MapReduce. So I hope if you've understood the election example and this example, you've understood MapReduce at a concept level, right? Anyone having does anyone still has a doubt about MapReduce? So, okay, let's now that we've understood a little bit about MapReduce, we've also understood about HDFS. Let's try to understand a little bit more, but we'll still not go into the depth. Okay, thanks. So there's something called a job tracker, then there's something called a task tracker. Now on the MapReduce engine, there's something called a job tracker and a task tracker. Okay, on HDFS there's something called a name node and a data node. Okay, so the way it is divided is that HDFS will have a name node which will be the master node, and then there will be data nodes which will be slave nodes. Job tracker is the master daemon which runs and distributes the tasks to the task trackers. Which task trackers are the programs which will be running on the data nodes. Okay. For now, just understand that there's something called a job tracker and there's something called a task tracker. Job tracker is associated with the master node. The task tracker is associated with the data node. Okay, for now that's all, right? Task trackers data nodes are the polling stations. Task tracker could be the program which is running on for counting the votes at the polling station. Okay, tracker runs on the data node. Data node will be on a machine, and the tracker will be running on that node. Okay, so job tracker is associated with the admin node, and the task tracker is associated with the data node. Okay, is that clear to everyone? Just remember this much. Okay, it is like it is a service which is running, something like a Windows service or a Unix daemon. Okay, so just remember these terms that we've now understood what is map, what is reduce, we've understood HDFS, we've understood what a cluster means, we've also understood what is a name node, we've also understood what is a data node. These terms just become familiar with these terms. A map task is nothing but the map program of the, okay, a reduced program and a map program. Okay, Ananda, that question will be answered in a while if the name node is a single point of failover. Okay, let's move ahead. Let's look at the architecture of the HDFS. Okay, now this is a very important slide, so just make sure that you are paying attention to this and try to understand it once. I'll repeat it also, so don't worry if you do not get it in the first chance. Okay, I want you guys to spend a minute to understand this on your own without me speaking anything, and then I'll go ahead and explain you everything. Okay. Avni, daemon is like a service which is running a task which is running in the background. Okay, for now just look at this diagram. I'll give you maybe 2 minutes to look at it, and then I'll explain. Great. So everyone has seen what is happening here. When we write data into HDFS, will it go to the name node as the diagram is showing arrow? Okay. 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 So let me explain you how things happen here. Okay. Basically, this is the name node. Okay. All the metadata operations are happening at name node. What is metadata? Yeah. Metadata is data about data. So things like where is where is this data stored, which blocks will have this data, okay, things like that, okay, address to the data, that's right. File name, location, etc. are all about metadata. So all the metadata operations happen on the name node. So name node stores the metadata only. It doesn't store the actual data anytime. Okay. So there is a client. We will come to know what is a client as well. So there is a client which will be interacting with the name node for the metadata operations. Okay. Once it gets that, I'll be talking in detail about how the read and write happens. For now, you can assume that the client will interact with the name node for the metadata operations. Okay, and then the client will either read or write. So this client and this client are same. It is just for representation purposes that we put it at two places. This is the same client. Great. So yeah, coming back to that, what is a rack? Rack is a collection of machines where, I mean, it's a physical collection of all these data nodes. There could be 20, 40 machines in a rack, and that is where these data nodes are stored. Okay, so these are all data nodes. Now these can be, the rack 1 and rack 2 can be geographically separated out. One can be in US, the other can be in Australia, it can be in India, wherever. Okay. Sure. Okay. Let me just start from the beginning. Okay. So when I was talking about this, now a client could be, so first thing will be a client. Client will be either your HDFS command line. It could be a Java interface which you can interact with the name node. Okay. So the end user is talking to a client. Okay. End user will always be interacting with a client. So a client could be, say, an interface built over Hadoop, which you can, we will be looking at a few clients going forward. So it could be the command line interface where you can run commands on HDFS. Okay, it could be a Java-based interface on which you are using which you are interacting with the Hadoop cluster. So that's what the client is. Okay, and the end user will be sitting in front of the client. Okay. Now, the client will be interacting with the name node with respect to the metadata operations. So all the metadata operations will be done through client. Okay. So what does that mean? That means that if I have to find out what all data nodes are free, where can I write, or from where can I read a particular block, I'll be talking to the name node. Okay, name node will give me that information, and then I'll go ahead and read that data from either the data node or write that data into that. So this client and this client are same. This is just for representation purpose that we put it here. Okay, fine. So, and I'll be also going into the details of how a read and write happens. For now, you can understand from this architecture that there's a name node. There will be multiple racks on which the data nodes will be there. There will be multiple blocks on which, on a particular data node, the data will be divided into multiple blocks. Okay, and there will be a specific block size of this data. Okay, and if you have to read or write a data, you will first talk to the name node, find out the availability of that data if you want to read it, or find out the availability of space if you want to write it, and then name node will tell you, okay, this is where you can go ahead and read it, or this is where you can go ahead and write it. Then the client will go ahead and read or write from that particular location. Okay, is that clear to everyone, guys? This much is clear? Okay, so a lot of questions coming in. I'll just pick up some of those. The client can bypass the name node to reach data node. Client does not reach a data node through a name node. Okay, client always reads the data from the data node directly. It just goes to the name node, checks out where is this particular data will be located, because the metadata is stored in the name node. So it goes into the name node, checks that, and then goes ahead and reads it. Okay. Now, why is the data divided into multiple blocks? Whenever you are storing a data in a file system, it will be divided into blocks only. Say, for example, if you write a data into Unix, a block size of say 8 KB will be there, right? So basically, whenever you have to read or write something, okay, the client will be telling the name node, okay, this is where I want to read and write. So first thing which will happen is that the name node will be having, we will look at the configuration file, so this will become much more clearer. But name node will be updated based on the acknowledgements which we get based on writes. Okay, and don't worry too much about it right now. Going forward, when we talk about how does the write happen, this will become clear. That how does the name node get updated. Utpal, is this fine? Okay. So Utpal, see, when a write happens, initially the name node will be knowing all my full cluster is free. Okay. Then whenever you keep on writing, there will be an ACK which will be given back to the name node, based on which it will maintain that, okay, now this is occupied, this is free. Okay. Yes, name node is also configurable. We will be looking at the configuration of the name node as well. Okay. Just give me 1 second. What is the use of rack? Rack is nothing but a physical location where you will have multiple data nodes sitting together, multiple computers together. Okay. Let me take. Okay. What if the name node failed? Is the data redundancy for name node? Omkar, just hold on this question. This will be answered in a while. We'll be talking about that. I'll just be talking about replication as well. If multiple people are reading and writing to a single file, name node maintains the inode info and locking mechanism. Yes, so basically that is done through MapReduce. Okay, that how does that multiple thing happen? That will be done through MapReduce. Once we reach the MapReduce chapter, you will get to know exactly how that happens. Does name node will also have the details about disk usage of data nodes? Yes, it will know that what all data nodes are free and what all not. How many blocks of data is divided into? Data will be divided into blocks of either 64 MB or 128 MB depending upon the configuration. Okay, rack is not a physical computer. It is like a storage space. It is a storage space where multiple computers will be stored together. Basically, a cluster will be a collection of racks. Okay, a rack will be at a single geographical location. You can store multiple data nodes in a rack. Okay. Now, there can be hundreds of racks in a cluster. Okay, the block size is 64 MB. Okay, so let me go forward a little bit, and then some of these questions will be answered. Otherwise, I'll take up more questions. Okay, racks can be in different locations in a single cluster. That's fine. Okay, name node also does some block level operations here with the data node. Okay, these operations could be the availability of the data node. There could be availability of the how much is the size available on the data node, what is the whether the data node is available or not. Those are the kind of operations which the name node does on the data nodes directly. That is where the interaction happens. So this is what this is. Now, as I told you, right, these are commodity computers, so there is a good chance of them failing. Hence, a replication is built in the architecture itself. So each data block by default is replicated three times. So basically, this is if a data block is present here, it will be present here as well. Now, where is the data block replicated is something which we'll come to know in a while. But for now, you assume that each data is replicated thrice by default. It is configurable. You can either increase or decrease that as well. Yes, the client can read directly from the data node. It just needs to know where to read from, and that metadata is read from the name node by the client. Okay, this also will become a little clearer when we go to the read and write diagrams here. Okay. Okay, data node is a commodity hardware. What is the configuration of it? Now, as I told you, can go ahead and read those powered by link. You will see what is the kind of configuration people use for this. Usually, it will be a normal Linux box, which you can have a 2 terabyte of the storage, something like a 4 GB of memory or a 16 GB of memory, depending upon your configuration. But we will also look at some of these aspects going forward. For now, you can read through that what are different people using for different things. Okay. The protocol used is RPC here. Okay, remote procedure call is used for talking. Okay, no, there's no replication in a single node cluster. The replication happens on multiple nodes, and it is used if a node fails, then this will come in. Okay, very good question. These data nodes can be hosted on a SaaS thing as well, wherein you can host the complete cluster on something like Amazon Web Services as well. You need not have these physically on your location. You can have them on a cloud itself. You can build them on cloud itself. Okay. Okay. What if all the 3 data nodes fail at the same time? Will we be able to recover data? No, you will not be able to recover that data. Okay. Let me proceed. Some of these questions which you have will be answered. Okay. So now let me quickly revise what I wanted to tell you in this slide. And a lot of things which will remain unanswered, let them remain unanswered for now. Just understand what I wanted to tell you now. And if you are all okay with that, give me a yes. So in this file, I wanted to tell you that the communication between name node and data node happens through a client, where a client, and give me a yes if you've understood this, right? A client, all the metadata operations are done by client on the name node, which include where is the file located, where can I read a file from, where can I write a data into, okay, and then the client directly goes on, gets that information where to read or write, then the client directly goes and reads from the data nodes. Okay, these data nodes are collected in terms of racks in a single geographical location. A cluster can contain multiple racks across multiple geographical locations. Okay, a client can do a read or write both. Then, since these are commodity hardware computers, there is a chance of failure. So you basically, what you do is that you replicate the data across minimum of 3. That is the default setting, that all the data is replicated across 3 places. Now, what are these 3 places? Whether it is in a rack or it is in the same rack or a different rack, all these things will come to know when we talk about rack awareness in this class. Okay. There's no replica limit. There's no limit on the replica, but but default limit is 3. Usually people will do 4 also, but more than that it becomes too much of a overhead. Okay, and most of the things can be handled by a 3 limit itself. Okay. Now there is a question that the write operation in diagram is a bit confusing. It is not talking to a name node. Don't worry about that, Praneeth. I will be talking about the write operation once again, but just to clarify, in the write operation also, the client will go ahead and ask the name node where to write this data. Name node will tell it, this is the place you can write, and then it will go ahead and write. Okay, great. So if this architecture diagram is clear, you have gained a lot of knowledge today. As I said, the block level operations will be operations happening between name node and data nodes, which can be based on how much data is available on a data node. Is the data node really working properly or not? These are the kind of operations which will happen on between data node and name node. Okay, so let's move ahead from here. Okay, some of these things will become clear, guys. Just hold on for some more time. Let's look at the name node and a data node, and a lot of questions about failover and all will be answered here. So name node, as you can see here, is can you identify this car, guys? Everyone can identify this? Okay, a lot of people have been able to identify it is a Lamborghini. Okay, now a name node is like a Lamborghini. It is the master of the system. It maintains and manages the blocks which are present in the data node. Now this is a very, very high availability machine. This will be a this will be a machine which you will probably, it will cost you a lot of money, but the whole idea is that in Hadoop, this is a single point of failure. Now, just to be very correct, in Hadoop 1.0, it is a single point of failure. I'll talk about 2.0 as well, as I promised you in the beginning, but let's assume that since it's a single point of failure, this is a very, very expensive, high availability machine with multiple processors working in parallel there. Okay, and it is a single machine in a complete cluster. There is no multiple name nodes. There's just one name node in a machine. Okay. Okay. So typically, this could be a RAID machine as well. And if you want to know about the exact architecture, exact configuration of this, I'll send it to you in a note separately, Ashutosh. And for everyone else as well, we'll have something there, right? The typical configuration of a name node and a data node, I'll share that with you. Okay. Now, this will have, say, multiple power sources. You will do everything which you would probably do in a Lamborghini to make sure that it doesn't fail. Okay. Whatever, there's no replica for name node. Just hold on. There is something, but not really. For now, you can understand, and very shortly you'll understand what are the other things associated with it. So it will be a very, very high quality, high availability machine with multiple power center sources. It will be kept in a place where it should not fail. It will not. There will be multiple processors running. There will be a huge amount of RAM associated with it. Okay, so all that is happening here. All the data which is stored is never stored in a disk. Here, all the data will be available in the RAM itself in the name node. Okay, so the best-in-class machine which you can get, you will use for name node. The exact configuration, I can share that with you. Okay. Now, what is a data node? Now, as we said, right, commodity hardware, and as you can look at this analogy, these will be like these ambassador taxis, which could be, you don't worry about the reliability. You can just, these will be huge, cheap machines which can be commodity hardware. Okay. Okay. So Venkat says the data nodes ambassadors are much stronger than the name node. Okay. The Lamborghini. Well, I mean, yeah, they are much powerful because all the politicians go in them, but they are still commodity. Okay, so like let me not get into politics right now, but at the same time, what I wanted to tell you here is that data nodes are plain commodity hardware. But commodity hardware is a normal machine. Your laptop can also work as a data node in a Hadoop cluster. As simple as that. No special thing about them. Okay, and they are bound to fail. Okay, they are assumed to be failing. We don't maintain a high quality machine here. So that's where the cost of the overall Hadoop cluster is very economical. You can use commodity hardware here. Is that clear, guys? So these are deployed on each machine, and this is where you don't need a high-end CPU on these data nodes. Smartphone also work as a commodity device with respect to Hadoop. I'm not very sure about that, Anup, but yeah, I don't mind you using a smartphone as well as a data node. Okay, as long as you can connect it through a RPC kind of protocol. Okay, but yes, the hardware present in a real high-end smartphone is as good as data node hardware. Okay, yes, reliability. You don't worry too much about the reliability here. Okay, and these are the machines where the actual data is stored. Okay. Okay. Now let's look at what is stored in the name node metadata. Is that clear, guys? The earlier page is clear to everyone with respect to name node and data node. Can I quickly get a yes? Okay. Failover. I'll tell you failover in a while. Just try to understand what is it all about. Failover will be in the next coil itself. We'll be talking about failover. Very good. Now let's look at metadata. So one very important thing: entire metadata is stored in the main memory, which means in the RAM itself. Okay. There's no demand paging of FS metadata. So entire metadata stored in the main memory. Type of metadata is very simple. These could be list of files, list of blocks on each file, list of data nodes for each block, file attributes, etc. Okay, so overall directory structure is maintained here. A transaction log will contain the record file creation, deletion, etc. Okay. Demand paging means that in a OS, usually when you do not have some data available, you go to the disk and read that data. So in this case, what we do is the entire metadata is kept in the main memory all the time. Okay, that's what demand paging is. Is that clear, Alvin? We don't have such a scenario. There's no paging at all happening here. Great. Okay. Now, what happens in case the name node fails? And we are talking about Hadoop 1.0 itself right now. Okay. So in case the name node fails, in 1.0, Hadoop name node is a single point of failure. In case it fails, there is a fire or whatever happens, right? There's a low probability of it failing because it's very high availability machine, but if it still fails, what happens? There is something called a secondary name node. Now, a secondary name node, the name is a misnomer, by the way. What that means is the secondary name node will not take over in case of a failure. Okay. The secondary name node is just used as, it is not a hot standby, which means that if the name node fails, the system is going to go down. The secondary name node will not take over. Okay. What will happen is that, but at the same time, all the data which is there in the name node is getting checked in, or it is getting replicated on a disk using a secondary name node. Okay. So it does the housekeeping and the backup of the name node metadata. So every few minutes, the secondary name node will come and take the data of the name node, metadata of the name node, and store it in a disk. In case of a failure, what will happen is that you will look at that secondary name node status and restart the system from there. So it is one very important thing. You may be asked in interviews, you may be asked in certification exams. Secondary name node does not take over in case of a failure. In case of it is just a disaster recovery kind of situation, right? So if for the recovery, you will come back from a specific checkpoint. Say half an hour back, the name node had taken a backup, and your name node fails at half an hour's time. Then you will only be able to recover the system from half an hour back. Okay. We'll also be emulating this thing in our class too. We'll see how the name node recovery happens. But for now, you can understand that this is just a backup taking mechanism, and this is not going to replicate, it is not going to come as a hot standby in case of a name node failure, right? So the secondary name node does not work as a name node when the failure happens. Okay, is that clear to everyone, guys? Yes, the secondary name node can be somewhere else on the WAN, right? And there can be multiple secondary name nodes as well. Okay, if you want to draw an analogy, the ambassadors can be your data node, your Lamborghini could be your your name node, and say a Camry or a Civic could be your secondary name node. Okay, yes, this can be huge drawback in case there is a failure. Yes, that is why in Hadoop 2.0, we have introduced something called a active and a passive name node. We'll talk about that in a while. Okay, I'll be talking about that. But in Hadoop 1.0, which is used in most production servers, in most production environments, a single name node is used. Okay. There's no way to get that data lost. That is why you use the Lamborghini, or you don't expect a Lamborghini to break down every time. Okay, so that is why you use a Lamborghini there. Yes, there will be a time lag if the name node fails, but the probability of a failure is very, very low. Okay, that is why we have used the best machine possible there. Okay, the secondary name node will be taking a backup all the time. At regular intervals, it will be taking backups. Okay. Okay, Sushil, we will be looking at the name node recovery process in the next class. Okay, so your question will be answered there. How do we? There will be a loss of data. Obviously, whatever data will be lost between the last backup and when the name node fails, that data will be lost. There's no way to recover that data, and that is the only reason why we use a Lamborghini there, right? Okay, let's move ahead. Annie is back and she wants to ask you a question. Okay, so you guys have all of you have understood it very well. It's a single point of failure in a cluster, runs on an enterprise class hardware, stores metadata. Now Annie is very kind in this class. Okay, so she's asking very simple questions, but trust me, going forward Annie will become as she looks. Okay, she will be very, very angry if you don't answer it right. Okay. So the right answer here, I believe, is all of the above. Name node stores metadata and runs on reliable, high quality hardware because it's a single point of failure in a Hadoop cluster. Okay. Utpal says, let us see. And he is actually challenging you. Okay. And Utpal finds Annie cute. Annie is smiling. She doesn't smile a lot. Okay. Great. So let's see. Let's move ahead. So this much is clear. If you are able to answer this question from Annie, then I believe you've understood about name node and about single point of failure. Okay. Okay. Richa wants me to explain single point of failure once again. Sure. Okay. So basically, in a Hadoop cluster, if the name node fails, there is no other node which can take over in case of failure. Okay. The system will go down. It will be a single point of failure. There's no other place where you can go and ask for a backup. Okay. So, but there is something called a secondary name node which keeps on checkpointing the data at regular intervals. Okay. So, so basically, what happens is that after say every hour or half an hour, and it is configurable, you keep a checkpoint of whatever is there in the main memory of the name node. Okay. So you know the state of the system is checkpointed on the secondary name node. Okay. And when a failure happens, you will go back to that state and you will recover from there. Okay, is that fine, Richa? And everyone else? Great. So let's go ahead. Another question. Now Annie is testing you and testing me as well, whether I was able to deliver that properly. Okay, I believe all of us have beaten Annie. So the answer to this question is false. It doesn't take over. Okay, the secondary name node will have copies, or it keeps a few backups. It doesn't keep everything. Yes, there will be a bottleneck due to one name node in the framework. Yes, but that is a trade-off which we have to take, Pankaj, that there will be a bottleneck because of one name node, but we are using a very, very high availability machine. So the probability of name node failure is very, very low. I have actually never seen a name node failing in my career. Okay, so I can tell you that this doesn't happen a lot. You can replicate a name node, and that's what happens in Hadoop 2.0. Okay, so we will be talking about that as well. So there is a mechanism of active and passive name node in Hadoop 2.0 Avni, and that is what is different in Hadoop 2.0. We will be talking about it towards the end of this class when we talk about Hadoop 2.0. Okay, is that fine? But in Hadoop 1.0, which is used in most of the production environments, there is just a single name node. So let me move ahead. The answer is false here, and everyone understands that. Using edits and FS image stored in secondary name node, don't worry about it. In the next class, I'll tell you what is the edit and what is the FS image. Okay. Okay. Now let's come to a very, very important set of foils, which will be 4 foils in a row. One thing which I want to tell you is, you may not be able to understand everything on these foils in a single shot in this class. But still I'm introducing these because over a period of next 2-3 classes you will understand everything. Okay. But I'll try to see what the max you can understand from here. Okay. There is the flow of jobs in say how does the job tracker work, how does the task tracker work. Okay. So basically what happens is the user will first copy files into DFS, which is move data into the Hadoop DFS, right, or the HDFS, right? Then it will submit the jobs. It will submit a job to the client. This is the user which is submitting a job to the client. Okay, how does it happen? We'll look into the next class. Now, the next important step is that the client will get the input file about information about the input files. Okay. Based on that, it will create the splits. So the user is you or I. Okay. Who is the user? The user is you and I. Okay. Then it will create the splits on that file. Okay. Now, how are these splits created? What are the considerations behind creating these splits? I will be telling you in class 3, not right now. But just assume that, okay, user is the person who is using the client. Okay, client is a software. Client will be creating splits on this complete file. Okay. Now, second thing will be the whole data. Say, for example, if you had to do some analysis on that complete data, you will divide that data into blocks or splits. Okay. Files are not copied through client. Files are copied using, say, Scoop or Flume or any external client. Okay. 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 So files will be loaded into the DFS using a lot of mechanisms. We will be looking at data loading techniques in the next class. So as I said, right, not everything you will be able to understand in this class. Just try to concentrate on what I'm saying for now. Okay. So these files are copied into the DFS. The client is going to split these files based on some considerations, which I'm not telling you today. I'll be telling you in class 3. And this whole data will be divided into multiple splits. Okay. On these splits, you will be running a job. Now this job will be basically a map reduce kind of job. Okay. And job.jar or job.xml contains that actual job, the Java program which will be run on this. Okay. So this will be contained in this. Okay. Then once you've submitted the job will actually be submitted through a job tracker. Okay. The job tracker is the master daemon which runs on the name node, which will be responsible for splitting running these jobs onto multiple data nodes. Okay. Now this data may be lying on the DFS on multiple data nodes. It is the responsibility of the job tracker to take care of that. Okay. So I'll move ahead now. Just hold on with whatever you've understood. I'm sure you'll understand the complete flow once I'm done with it. So next foil, your client has submitted the job on job tracker. This has come from the earlier foil itself. What you do now is that the job is initialized on the job queue. Okay. The job tracker creates maps and reduces. The maps and reduces are created based on what is contained in a map and what is contained in a reduce is determined by this job.jar, which is written in your Java. Okay. So in your what will contain in the map function, what will contain in the reduce function is written in your program. Based on your program, the job tracker will create the map tasks and the reduce tasks. Okay. So these map tasks and reduce tasks will be run on these input splits. Okay. So number of map tasks will be equivalent to the number of input splits. Now you remember these input splits were created by the client based on some considerations which I have not told you, but this will be the input. This input split will contain the whole data. Okay, the whole data which you had on the DFS is divided into these input splits, and each of this input split will have a map job running here. So you can assume an input split to be like a poll booth. Okay, and a map task will be running on that input split to do some analysis over it, and the output of the map task will go into the reduce task. Okay, as we saw earlier as well. Go back to our analogy of that polling and you will come to know about it. Okay, so on this file what we saw, the task was submitted based on your definition of the map and the reduce task which were there in this Java file. Your map and the reduce tasks were created. The number of map tasks is equal to the number of input splits which were there. On each input split, a map task will be run. Okay, and the number of reduce tasks will be generated based on the number of reducers you have defined, as well as the output of this map task will go to the reducer. Okay, and the job tracker will be tracking all these things happening. Okay, fine. Okay, there's a question. The ability to define the number of reducers lies with whom? It is configurable as well. Okay, you can define it in your Java program as well. Let's not get into that right now. Okay, but okay, let's move ahead. Now these map tasks are actually have to run on a where will these map tasks run actually? Can someone tell me this answer to this question? Very good, data node. Very nice. Very good. Very good. So through the task tracker, it will be running on the data node. Very good. So on the splits are where? Splits are present in the data node, right? Very good. So till now, I think you've understood. Is the same instance of map job assigned to all input splits? No, there will be multiple instances of map jobs. Each map instance will be assigned to one input split. Okay? So everyone is clear with this? These are the map tasks which have to ultimately run on the data node. Okay? Let's go ahead and let's see what happens here. Now, this is your job queue. Okay, this is your job queue where the job tracker is running. What the job tracker is going to do is that it will look at, I have to run this particular task on this particular data. Okay, now it will look at whatever is the, it will pick task tracker, whichever task tracker contains the data on which it has to run it, and there can be multiple replications of that. So it will try to pick the most local data as possible and run that map task on that particular task tracker. Okay, so the task tracker is the one which actually runs that task or the map task on the data node. Okay, task tracker, the job tracker will pass on this information to the task tracker, and task tracker will be running that job, the map task on that data node. Okay, is there a direct relation between splits and data nodes? Maps and input splits are same. Okay, two questions have come. I'll answer one by one. Input split is the split of the data. Map is the program which is run on that data. Okay, so they are not same. Map is the program which will be running on the input split, and input split is created from the whole data set which you have. Okay, now input splits will be residing on the data nodes, but how are they? How do you split on based on what consideration? Whether you should split based on block size or whatever? We will be looking at that in class 3. Okay, I'll be answering that question in class 3. Input split is done by the client itself. Okay, so let's not worry how the input split is done. For now, just assume that the whole data is divided into multiple input splits. On each input split, one map task will be run. Is that clear with everyone, guys? Great. Okay, so let's move ahead and let's see what happens once the job has been assigned to the task tracker. Now the job has been assigned to the task tracker. What the job tracker has to ensure, okay, Prakash says it is not clear. Now what happens here is that there is a heartbeat associated with each task tracker with the job tracker. Now the job tracker, what it does is it keeps on sending heartbeats to the task tracker to figure out whether the data node is still alive or not. Now we know that it is very much possible that the data node may die. Okay, it is on a commodity hardware, so it is possible. Don't worry, Ananda, I'll make sure that it is clear. I know some of these concepts will not be clear because there is a complete architecture of Hadoop including MapReduce. So it is very much possible that you may not be completely clear on this now. Going forward, as we move in by class 3, everything will be clear. So just hold on if you have not understood everything. Okay, but wait, but let's see how it is working here. I'll repeat this as well. This is the last file on this particular topic. So how does the job tracker come to know that the task is really running? What it does is it keeps on sending a heartbeat. Okay, and if it gets a heartbeat back, it knows that it is running. Like the way I keep asking you, is it clear to everyone? The job tracker sends heartbeat to task tracker. The job tracker will always be talking to the task tracker. Data node is the node on which the task tracker will be running. Okay, and if it sees that okay, there is a task tracker which is not giving me a heartbeat back, I'll know that okay, this particular task tracker is gone. So I'll assign this task to some other task tracker where the same data is replicated. Is that clear, guys? So let me quickly repeat this once again so that everyone is clear. Okay, what will happen if job tracker fails? Job tracker failing means name node is failed. So you know what happens then, right? Job queue has all the jobs which are associated with the task trackers. Prem, is that clear? So all these tasks are maintained in this job queue. Map task, right? Okay. Let's look at how does it happen. The user is you and I. You move your data into DFS in the Hadoop. Yes, it is that way always. Okay. So user is you and I, and let's understand this. Then I'll take questions once again. Okay. User is you and I. You move your data into the DFS using say Scoop or Flume or whatever mechanism. You can copy the entire data. There are multiple data loading techniques. We'll understand them in the class 2. And then on this data, you want to do some analysis. So you submit a job to the client. The client, the first thing it does is it gets the file input files info. That what is the size, where are they located, all that info it will get. Then the client will divide this complete data into multiple splits. I have told you earlier, how is this splitting done? I will not be explaining today. I'll be explaining that in the class 3. Okay. So Praneeth, just hold on for that question. I'll be answering that. Okay. Just listen to this clearly first. So client will split the complete data into multiple input splits. Then it will upload the job information. Job information means that whatever program I wanted to run, say for example, if I want to do a poll counting, then the map task will contain count the polls there, the reduce task will contain do the consolidation. If I wanted to do the encryption, the map task will contain the encryption algorithm, and there will be no reduce task, right? So all that is contained in this job.jar, which is a Java program and nothing else. Okay. And then the job will be submitted to the job tracker. Job tracker runs on the name node. Job tracker knows that where all the data is stored, where are the task trackers running, okay, and how do I send the data to all these. Okay. So this is submitted to the job tracker. Is this slide clear to everyone, guys? Any confusion here? Can I quickly get a yes? Let's get to the next one. The next one says you submit the job. It's the same replication of the same thing, earlier repetition here. So submit the job to the job tracker. What does job tracker do? Job tracker is going to read the job files. These job files are basically nothing but the map task and the reduce task. Okay. Okay. Copy of input file doesn't happen through client. No. Copy of input file happens through say a external. You can copy it through Scoop, Flume. It is like moving data into the DFS. That's one question. Let's be very clear about it. Don't worry too much about it. We'll be telling you various data loading techniques in the class 2. Okay. Second question, when a user copies into DFS, is the data getting stored into data nodes? That's right. Now the third question, who creates the job files? The job files are created, Avni, by you and me, people who will be writing the MapReduce program. So this is nothing but the jar file of the actual program which you would have written. Okay. This will be, depending upon your use case, whatever program you want to write, whatever logic you want to write, this will be contained in this. Based on this job files will work on input files. That's right. So yes. So using the job files, you will be creating maps and reduce jobs. Okay. Job file will tell you what should be done in a map task and what should be done in the reduce task. How many reducers are required? That is all a map reduce job will contain. Okay. Right? Well, let's not worry about what all splitting considerations. We'll not worry about it right now, Avni. Okay, just assume that the splitting is done based on some considerations. Okay. Don't worry about it right now. In class 3, I'll be getting into details of how the splitting works. Okay. For now, just understand the splits are done by the client based on some considerations. Then based on what is written in the job, you create a map and a reduced task. And the number of map tasks will be equal to the number of input splits. Each of the input split which is created will be on that a particular map task will be run. Okay. The output of that map task will go to the reduced task. Okay. Is this clear then? Then once you've created those map tasks and the reduced tasks, you have to run those tasks, right? Okay, Vijayan is asking me, user might do different analysis, how job tracker will know what jar file should read in step 8. So when you run a map reduce task, you will be giving a specific jar along with it. So you will be running a program on Hadoop, right? That program, whatever jar file you give, that analysis will be done. We are assuming that this is an input to Hadoop, that this is the job I want to run. Is that clear, Vijayan? If you run a poll mechanism, then it will be done. If you run a encryption algorithm, then the job will contain the encryption files. Okay. Now, once you've created the maps, you have to run them. Where will these be run? Don't worry about job.xml right now. I'll be telling you that in class 3. Okay. Just assume that it contains job-related information. It contains Java program. Just assume that. Okay. Then you will have to run these. How do you run these? You will be running, now this will be put in a job queue, which will be governed by the job tracker. The job tracker will assign these tasks to the task trackers, which will be running these particular map jobs, map tasks on different data nodes where the input split is actually residing. Okay? Is that statement clear to everyone? That after the maps have been created, they will be run by the job tracker on the task tracker, okay, ultimately on the input split which is residing on the data node. Is that statement clear to everyone? Can I quickly get a yes? Now, since we know that these are commodity hardwares on which these jobs are running, there's a chance of failure also happening, right? So keep a track on what is failing and what is not failing. The job tracker keeps on sending heartbeats. Okay, so if I send you a heartbeat is like, can everyone tell me if you are alive, if you have understood? The answer which you tell me yes or no is like a heartbeat. Okay, you understood what is a heartbeat, Prakash? If you give me a yes, that's a heartbeat. If you don't give me a yes, I'll assume that you're not there at all. Right? Okay, let me get a heartbeat from everyone. Has everyone understood this part? Can I quickly get a heartbeat, guys? So I've got a heartbeat from a lot of people now. Good. So this is a heartbeat. If someone doesn't give me a heartbeat, for example, Richa did not give me a heartbeat, I will assume that Richa would have probably lost her connection. Okay. And I'll not ask a question from her, but I'll ask that question from Avni, for example. That's what the job tracker also does. Okay. Is that clear, guys? Is that clear, Avni, to you? Okay. There can be more than one maps running on a task tracker. Don't worry about those considerations right now. In class 3, when we get into map reduce, we will be talking about it. Okay, Jatinder? Just hold on for now. Keep these questions for class 3. Okay, so Annie is back, and it was a complex topic which we understood just now. So you'll have to answer this. Hadoop framework picks which of the following daemon for scheduling a task. So if a heartbeat is lost, then the job tracker or the name node will assume that that machine is gone, and it will assign the task to a different machine. Okay, Ananda? Let's see what Annie says here. So job tracker will be taking care of all the job scheduling and assigning tasks to the task trackers. Is that clear, guys? Everyone got the answer right? Annie will be very angry with me. She is my enemy. Okay, she always wants my students to fail in her answers, but it looks like we are able to get all the answers right. So Annie is really furious. Great. So now that we've understood a very, very important thing, we are almost towards the end of our session. There are 2-3 things which are left, and yeah, you can say name node, but name node is associated more from the perspective of that node, and job tracker is the daemon which does all the scheduling on the name node. Okay, Ananda? Okay. Now this is how a write happens. Now a lot of people had the question that how does the write actually happens. So let me quickly tell you how does the write actually happens. So initially when I was explaining you about write, what did I say? I said when you have to write something on the file, the client will tell the file system that I want to write. Okay, create command will be sent to the name node. Name node will come back and tell where is the availability. Okay, where is the availability? Where can I write? Okay, that's what name node is going to tell me. Okay, now I'll go ahead and based on that, it will tell me if the replication factor is 3. It will tell me, okay, these are the 3 place name data nodes where you're going to write. Okay, client is going to pass on that packet to the first data node, which is in the pipeline of that data nodes. Now this packet will contain is the actual data to be written, the location on which it should be written on first data node. It will also contain the location on which it will be written on the second and the third data node. Okay, so if the replication factor is 3, let's assume that. Now this data came in here, it has written the data here, it will then move on to the next data node. Okay, this packet now will contain the data, the same data which was written here, the same data will be passed on, it will be written here. It will also, at this point, it will know the location on which I have to write the data on this data node, as well as the location of the data node, the third data node on which I have to write. So after the data is written here, a command will be sent, a write packet command will be sent to the third data node from here. This is happening in a pipeline fashion. Okay, this is done in sequential. Okay, this is done in a pipeline fashion. So once this is written, acknowledgement will come back from this data node that, okay, I have written it. Okay, this is not a posted write. You understand the difference between a posted and a non-posted write, guys? Posted write means that you don't give a receipt, you don't give an acknowledgement of that write. The difference could be something like a courier and a normal post which you send, right? A normal mail which you will send will not have an acknowledgement back, but a courier, if you send, it will give you a receipt back. So that is a posted write. Okay, a posted write is one without any acknowledgement. You just post it and forget it. A non-posted write will come back with an acknowledgement. So in this case, it is a non-posted write. What that means is that I want to get an acknowledgement back that the write actually happened before I start reading that data. Okay, so I'll send the data here, the data will be passed on to this, the data will be passed on to this, I'll get acknowledgement back, I'll get acknowledgement back. The final acknowledgement will be sent, I think the arrow is wrong. This will be sent back to the name node, and the name node will come to know that the write has happened, and then it will put it in its metadata that, okay, this data is written at this point, and next time when a read has to happen, it will read from this point. Okay. Okay. Why between the data node the ACK is sent and not directly to the name node? The reason is that we don't want the name node to. Name node is a high availability, very costly thing, right? I want to make sure that all the writes happen, then only the name node comes to know. I don't want to involve name node. I don't want to send my Lamborghini to buy vegetables. As simple as that. Okay, so the job is submitted by the framework. You tell the framework that, oh, I have to write this data, it will go ahead and submit the job. Yeah, I believe there is a 6 also which is missing. So I'm sorry about that. Yeah, there is no 6th state in this. Okay, so basically everything happens through a map and reduce only. Okay, so when we come to the map and reduce section, then we will be looking at that. For now, okay, how will the first node come to know where the second copy is to be written? This write packet which comes in will contain the information about the data which has to be written and where are the 3 copies to be written. So the first data node will know that after I have synced in the data in myself, I'll move the same data to the second node which is being told in this packet. When this data comes here, it knows where the third data has to be written. This data will move on here. When all this write happens properly, then the acknowledgement is sent back. This acknowledgement is sent back and this will be finally gone. Then the name node will come to know about it. What if the first node crashes while write? Unless and until the name node gets the acknowledgement back, which is this, it will assume that the job failed. It will rerun the same thing again. In this case, we are showing only 3 data nodes because the replication factor is 3. So a particular packet has to be written on 3 different data nodes because the replication factor is 3, and this is how that is accomplished. The way it is implemented in Hadoop, and I'll tell you why in a while. How does the client know before name node what if the other client from other system wants to access the same file. Okay. Okay, so there is just single name node. So there is no possibility of another client accessing the system from a different place. It has to get the information from the name node itself. There is single name node, right? This can have more than 3 data nodes as well. If you have more replication factor, there will be more than that. But you can assume that having more data nodes will have a cost associated with that as well. So the optimum number of data nodes for replication is 3. Ananda, your question is answered. So whenever I have to write something, I'll go to the name node. I'll ask the name node, can I write? It will say, yeah, go ahead and write it at this place, then I'll write. Okay, so how will the name node come to know which data node failed? It will also be monitoring it through your heartbeats. So it will know, okay, if the failure happened, it could have happened because of a network problem as well as due to a data node. So next time when it does not get an acknowledgement, what it will do is, the 3 set of data nodes will be chosen based on the status of what it has on the heartbeat. Okay? Is that clear, guys? Okay, so name node does not get 3 ACK packs. Name node will get only 1. Okay, and the acknowledgement, no, acknowledgement is not heartbeat. Heartbeat is to determine whether the name node is working, data node is working or not. Acknowledgement tells me whether write was successful or not. The write may be, the data nodes may be working perfectly, but the write may still be unsuccessful because of a network problem, right? So basically what happens here is that you go ahead and write if the acknowledgement also isn't sequential. Name node will not know where it failed. It will just know that it failed. I did not get the packet back. So there will be 2 initiations which it can do. One, it will look at all the data nodes. If it finds the heartbeats are fine, which means that there was no failure on the data node, it will give the same write packet to be written here. If it sees that, okay, there is a problem in one of the data nodes, in this write packet, the location of the second data node will be different. Is that clear, guys? If the data node failed, through the heartbeat mechanism, the name node will know that this data node is not working. So the second time when it sends the write packet, it will send the address of a different data node than the one it sent earlier, so that the write can happen at that. If there was no failure on the data node, it will send the same write packet once again to make sure that the write happens. Okay, is that clear? Okay, Praneeth, if any of this fails, it will be considered as a failure. If this fails or this point fails, this point fails, this point fails, everything is considered a failure. Only when I get this acknowledgement packet back and I send this to the name node, this is considered as done. Okay. Everything will be redone if it does not get the ACK pack. It will be rewritten. But the data was written on 2 nodes, it doesn't matter. It will rewrite that data. If the ACK pack is false, it will retry. If the task tracker was working fine and the ACK packet did not reach, it will retry with the same parameters which were in the first write packet to see if it can happen again. Every write is acknowledged. So see, if any of these points fail, say this network fails, this network fails, this network fails, or this network fails, or even this network fails, it is considered as a failure. The same packet will be written again, retried. And this time if it gets an ACK, it will say that it is done. Now when a failure happens, the name node also knows that there could be a failure in the data node itself. If it sees that, then it will not send the same write packet. The same write packet will have a different address of the second or the third or the first data node, whatever failed. Okay? Yes, there will be a timeout for ACK. There can be a duplicate entry. It will be overwritten. Say, you have understood it, but I don't know if you have understood it. I'll repeat it, right? Isn't it? So that's the same thing which the name node also does. Unless and until I get an ACK that everyone has understood, I'll probably try repeating it so that everyone understands that. Because the cost of my repeating is not as much as the cost of your not understanding the things is. Right? I am a cheap resource. I can keep on doing things again and again. You guys are important people. You should not be, your time should not be wasted. Okay. And all of you are considerate enough that if one of you is not able to understand, everyone else is considerate enough to wait and make sure that everyone is understood and then only move on. Right? Does that help, guys? Does that help in understanding? So let's move ahead. I believe the write is clear to everyone. I have not explained why we don't do write in parallel. Okay, I'll explain that in a while once we've done with the read. Okay, in case of a read, it's very simple. You go get block informations, do the read in parallel. You go ahead and read that data is what I'm doing right now. Okay, and read happens in parallel. Okay, now coming back to the, is this clear to everyone guys now? And there's no acknowledgement with the read. Why is that? Yeah, the data itself is an acknowledgement. Very good, Bhanu. Coming back, very important thing. Why do we read in parallel and why do we write in sequence? Because Hadoop is a system which is more used, or which is used for write once and read many times kind of analysis, right? You have logs which are written once and then you do multiple analysis on that. So on the read side, I have to be really fast. Okay. Okay. The read side has to be very, very fast. On the write side, it's okay. Let's take an analogy from the real world. Has anyone uploaded a video on YouTube? If you upload a video on YouTube, many a times it fails. Okay. And it takes a longer time. Okay. In uploading the video. While we are reading this, while we are reading a video from YouTube, it is very fast, right? And the use case is such that while you are uploading, you don't really worry that if it takes more time. I don't want to spend a lot of my resources on uploading a video. But when my video is ready and I want my users to look at it, then I want it real fast. Okay. So from that perspective, read has to be parallel. You have to present the data very fast. Okay. And in case of a write in a system like Hadoop, you have the luxury of time because you are not doing any real-time analytics. Okay. You first load that data gets loaded into the system. Once that data is ready, then you want to read it multiple times. You will not be writing the same data multiple times, so writing can be done without wasting much resources in sequence. Okay. Is that clear, guys, now? Okay, video will be, taking example of video will be stored in one data node only? No, it will be stored on, depending upon your replication factor, it can be stored on multiple data nodes. Is that clear? For now, very important aspect is how does the replication work and what is rack awareness, okay, in Hadoop. So just hold on for some time and let's try to understand. Now see, these are your racks, multiple racks. Each rack has multiple data nodes. As we said, these racks can be geographically at a different location, okay, and these are data nodes present in this rack. Now I have a block A which I want to write, and we have set the replication factor as 3. So the question that where this block will be written will be answered in this particular file. Okay. So you have a block A. Say for example, you write it in one. You write the first copy in rack 1 in data node 1. Okay. The second copy of this will be written in a different rack, and the third copy, if it is done, will be written in the same copy as the second rack but in a different data node. Why is it done? Two things. One, we want to make sure if we write it in the same rack, in case of a rack failure, you will lose the data. Okay. So in case of a rack failure, you still have the copy here. Okay. And then why don't we write this data here in the third rack? Why? Because the writing inter-rack communication is a huge bandwidth hogger, right? These could be at multiple locations as well. And the probability of 2 racks failing at the same time is very low. So with that trade-off, we don't waste a lot of time in moving this data from this rack to this rack. And we work with such a mechanism where the first will be written somewhere based on whatever data node, whatever the name node figures out is the closest to it. And the second and the third will be written in the next rack which is available, but in the same data node. Okay, in different data nodes. Now, if all racks fail, you are doomed. It is like if the fan on my head falls down, will the class continue? How will I continue the class? It is the same answer to that, right? It will not continue. Okay, so but there's a very less probability of the fan falling over me, and in this particular room there is no fan, so we are safe. Okay, so similarly, there's a trade-off between everything. You can be overly secure, you can do insurance for everything, but there's a trade-off here. So here is the trade-off that there's a probability of a rack failing. So to take care of the rack failure, you put it in a different rack. there's a probability of the data node failing, so you put it in the third copy is kept in a separate data node. Okay, is that clear to everyone, guys? This is how the replication happens. Now, because of this replication, this is how the replication has to happen. The name node has to be rack aware, which means that the name node should know which data node is stored in which rack. Okay. So that is what rack awareness is called. It is the name node which is telling us where to write, right? We've already seen that. So name node should be rack aware because it should know where I have to write. And replication is done based on this factor that there will be a rack there to take care of the rack failure. You write it in a separate rack, but on multiple nodes. Is this clear to everyone, guys? Can I quickly get a yes here? Good. Thank you very much. Another example, just to reinforce this. So you write, your first is written here. Can you tell me where will be the second and the third copies be written? Can you answer that? You can just name node name the data nodes. Okay, good. So it can go in here, it can go in here, it can go in here, not on the same rack, but whichever rack is chosen because of the proximity of the data, it will be chosen and the separate data node will be there, right? So is that clear to everyone? And if we have a third block C, then it can go here. It could have gone here as well. Okay, so rack awareness and replication is clear to everyone. These could be questions which could be asked to you in an interview as well. Okay, so make sure that this is very clear to you. Okay, okay. So Annie comes back and she wants to ask you a question. In HDFS, blocks of file are written in parallel. However, replication of blocks are done sequentially. Okay. So I believe some people have not understood the question properly. The answer to that is one which is true. See, what was this diagram telling you? This diagram was telling me one packet, if it is replicated on 3 data nodes, then this will happen in sequence, right? Right? But there can be multiple packets to be written on multiple places, right? That can be done in parallel. Okay, is that clear to everyone who gave the answer as false? The replication happens in sequence, but the data can be written in parallel, right? So is this clear to everyone now that the answer is true? Annie has won a little bit. So a lot of people, Annie, I told you, right? Annie will be happy this time. She is very considerate in the beginning. From next class onwards, the questions of Annie will be much more difficult to answer, guys. So be prepared, okay? And you should be very careful in reading the questions. Now, true, a file is divided into blocks. These blocks are written in parallel, but the block replication happens in sequence. So Annie has given you an explanation as well. Good. Now, another question. A file of 400 MB is being copied to HDFS. The system has finished copying 250 MB. What happens if a client tries to access that file? Can read up to a block that's successfully written? Can read up to last bit successfully written? Will throw an exception, cannot see the file until it's finished copying. So let's see what is the right answer and let's see how many. So do you believe that Annie is now getting a little smarter than us? Right. So yes, and if all of you got an answer yes, I did a good job. You can read till the block which was written successfully, right? That's what we said. You can read after you got the acknowledgement. Okay, Richa says no. So Richa, in our example where we were writing, we were saying that you can read after you get an acknowledgement. So acknowledgement is per block. Once you've written that, you got an acknowledgement, the name node can allow you to read that, right? And that is per block, not per file. A file can be divided into multiple blocks. The file can be incomplete, that's right. The file can be incomplete, but on the block size, so file is a logical thing which you have to take care of that, right? Whether you want to read or not. Whether you want to read or not is your choice. But you are allowed to read that. So when you say bit successfully written, and it is an application dependent thing. You are right, Richa, that in case of videos, it doesn't make sense to read it. Okay. But there can be scenarios where it could be good to go. Yes, so Mayank, as I said, right, I mean, it depends upon the scenario. On the HDFS, you will be able to read that. But in case of a video, for example, it doesn't make sense to read it before that. So YouTube doesn't allow that. That's the client which doesn't allow you to read that. Yes, but it is written, write it successful, only on the 3 blocks are written and the acknowledgement is written right. That's right. But that is for each block and not for a file, right? Whatever we did right, we did here, right? Whatever right we did here was for each block. You wrote a block of data. When you got the ACK, you are ready to read, right? Is that clear now? So these could be questions you could be asked in interviews. Okay, so be very, very clear there. And can I store 400 MB of video block by block on data node? Yes. So depending upon the block size you've defined, you could store it in 64 MB blocks, or you can store in 128 MB. Just give me 2 minutes. Just give me 2 minutes. I'll be talking about what I have to do next. One is go through these files, some of these blogs. You will understand a lot of these things here as well. Make sure that you go through them before the next class. Second is, before the next class, there's a pre-work of this class. I'll also be sending you an email with the details. So in case you're missing this, don't worry. Set up the Hadoop development environment using the documents present in the LMS. So in the LMS, as I showed you earlier, there's the place where you can find the installation docs. This is the CDS3, which is Hadoop 1.0. This is 2.0. You can use both. Okay, you can set up both on your system. You cannot work on parallel both of them unless and until you have a real big machine. But we'll be working mostly on CDS3 and sometimes on CDS4. So I would suggest that you install both. For installing, you can download the file here. If you need any help, there is a team which can help you out. You can send an email to hadoop@edureka.in. The ticket will be logged. The team will help you out. Okay. So this is how this is where you'll find the deals. You can also go through the Java essentials for Hadoop. Before coming to the next class, I'll request you to execute some basic Linux commands as well after setting this up. Okay, and I will also show you where to find them. So here are some basic commands on Linux. You can go through them. Okay, I will request you to try them out if you're not a okay, on a Windows 7 also it will work. It is a virtual machine, so it will work. Okay, so next is this Hadoop hands-on, where we will be, yeah, so this is class 1. So this is where we have started the course. Okay, so next is Hadoop hands-on. You can download this as well, and you can have a look at this as well and try out things. But don't worry, the prerequisite is that you should have this setup done on your systems before you come to the next class. We'll be doing some hands-on there. Okay, you don't have to install Linux. You can do it on a Windows machine using a virtual machine. So these are all VMs which will have their own Linux or Ubuntu installed inside. Okay, is that clear, guys? Okay, thanks Nirupam. Nirupam says, thank you, Abhishek, enjoyed the class, exceeded my expectations. Thank you very much. Yeah, thanks everyone. You can send over your questions. I'll take your leave now. I think most of the people have left the class. Please don't forget to, whoever is here, please don't forget to fill in the final survey report. Okay, thank you very much. Thanks, bye-bye.